Sir, your screen is visible, sir.
Thank you so much for confirmation, sir.
Welcome, sir.
So if anyone feels that my voice is breaking, just kindly inform me, even though the session is in the progress.
Okay, sir. We are in the back end, sir.
Yeah. Thank you so much for your kind words, sir. And I would like to thank Dr. Indra Devi Madam, like she kindly given me that very good opportunity to me to have a discussion with the number of professors who are available here. I believe all are teachers, all are professors from the different institutes. Am I correct, sir? All
Sir,
are
good morning, sir. Arvind sir, good morning.
Good morning. Good morning. Good morning. So, all our professors over here.
Thank you, sir, for your immediate acceptation when we are requested to you. And in
It's a
spite of your
pleasure.
busy schedule, you have accepted. And we should say thanks to Dr. Muruganandan sir also, who has given your contact number.
Okay.
Thank you
Okay.
very much, sir. And
Thank you.
let us have the session right now, sir. Thank you.
Yes, sir. Thank you. Thank you. It's my pleasure to give it. And Muruganandam sir is a very good friend of me, and he is my well-wisher too. So I will agree whatever things that Muruganandam sir said actually. Yes. So I believe all our professors over here, and I can able to give a quote as a professor, right? Everyone. Am I correct? All are teachers. Any students are over here? Any PG? Any students or any research scholars? Anybody is here in this today's session? All are teachers.
All our teachers only, sir, from faculty, from
Yeah,
polytechnic
fine.
and engineering.
Fine, fine. Okay, madam. Okay, okay. Thank you so much.
Thank you,
And
sir.
professors, you are all feel free to chat with me. And just if you want to make it into anything to be make it convenient, you can just break the session and you can ask the questions, no problem. Or otherwise, you can able to take the question at the end. So whatever may be that way, I'm just ready for that. And thank you so much for the invitation. And today's session, we are going to talk about this set of things. Especially, I'm here to give a presentation regarding the topic called network design and architecture. So, what are all the basic network designs and architectures going to get required while you are dealing with the Internet of Things, actually, right? So, so since we are starting with the session, so there should be some objective. So, what you're going to be learned today. So, in today's session, I have an objective. I have four objectives today to introduce about the IoT. Since you know about this IoT for past 2 days, I believe I'm just taking third day's class so that you know well aware about what is mean by this IoT. So don't afraid that I'm going to be stick on IoT very deep because I'm going to give a small intro about IoT, and I'm going to give more concentration on the significance of the network architecture which is required for IoT today, and then what are the different classifications which is available in the IoT topologies or IoT technologies we can call taxonomies or classifications which is existing in the IoT technologies, and then what are all the design considerations we have to be take care while we're going to IoT projects, and what are the different types of applications which is available in the market, or what are the different types of applications which are developed based on the IoT technology. And these are the four important session objectives for us to complete. And I believe once you complete the session by 11 o'clock, you may take away to your home by the concept of like the different network architecture of IoT. You may know the different network architecture of IoT, and you know the differences, how come it is going to be getting differentiated, and you can able to understand the what are the different classifications of research is available in the IoT area, and also you may understand what are the current developments is going to be happening in the IoT. So that is what my um, target today to complete this today's session. So with this objective and as well as with the outcome. Right? So so today's we know all are like the internet is going to become one of the unavoidable things in our everybody's life, and also especially in this pandemic situation, it's just proven that we just adopted whatever the technology which is available in and around us. We just made use of it. Even during the situation, we just made the teaching learning process very effective by using this internet, especially. So no one is not going to say no, right? And even we just proven that there is no any requirement of physical laboratory, because we just adopted some virtual laboratory, what is in the IITs and NITs, especially in the MHRD portals. There are different virtual labs that are available. So we try to adopt the particular virtual lab, and we proven that the students can able to even do the experiments without any physical component, right? So everything is made possible only because of this, the internet, right? And also it's just touched almost all over the globe, and we can't able to say that it's not happened. Unfortunately, knowingly or unknowingly, we can say that it's going to be affecting the human life in different ways, in different scenarios. Madam, yes. Is there any problem in your voice?
No, sir, no, sir. I will take care, sir. 1 second, sir. It's maybe cross talk. I'll do,
Okay.
sir. Yes, sir.
Okay. Okay. That is a scenario.
Is
We
it
are
madam?
just shall I continue? Okay, I believe the problem got resolved, right? So everybody's life is going to be getting touched with this internet, and now we are entering into the era like even where the IoT is going to be coming to picture. We can even say that the wide varieties of public appliances will be connecting with the internet. That's what we are seeing. Even starting from the your home to the even to the vehicle. Like you may all of you heard about one of the vehicle is more popular in the market called MG, right? That it comes under the Internet of Things. In advertisements, they used to say IoT enabled automated vehicles called MG motors, right? So that is the impact what is created by this thing like that. So when I say IoT, we can able to hear a lot of different definitions will be there, and different descriptions will be available for the IoT, especially the researchers, those who are working in this IoT area, they may give a different definitions based on their perspectives. So among that, even though we have n number of definitions are available for this IoT, I have two definitions very particularly. So one, I can able to say that like this IoT as simply an interaction between a physical and digital world. Am I correct? It's just simply a interaction between a physical and the digital world. Like the digital world interacts with the physical world using some collection of sensors and actuators. That's what we're just seeing, and that's what we try to do by using the Arduino. That's your topic of your this STTP, Internet of Things, adapting the Arduino, right? So your digital world is going to start to interact with the physical world by using some collection of sensors and actuators. That is one of the fine definition of what I found. And IoT is a paradigm in which the computing and networking capabilities are embedded in any kind of conceivable object, right? Conceivable object. So this is another way in which we can able to define this IoT. So in common phrasing, the Internet of Things or the IoT is referred to new kind of world where almost all the devices and appliances that what we are using is connected to a network, that no one is going to be forget about that. So for this intelligence interaction, right? IoT devices are equipped with embedded sensors, actuators, processors, and what else? And transceivers and many more. So when I say these sensors and actuators are the devices which help to interact with the physical environment, as especially when I say the temperature sensor, when I say some chemical sensor, when I say some pressure sensor, it just try to interacting with the physical environment, and it is just try to make the system to understand what happening in the environment and what are the changes going to happen in the environment with respect to the change in the electrical signal or change in the any form of electrical physical quantity variation going to be happen based on sensors. Am I right? So, and also the data will be collected by the sensor and has to be stored and processed very intelligently in order to derive the useful interferences from it. So that is the need of the sensor and actuators, what we are needed by this IoT. That is the reason why I just kept over here as the slide. IoT is not a single technology, it's a collection of multiple, like a sensor and actuator, storage and processing of data, and communication of HTTP. So when I look into the point of the storage and processing of data, why we need the storage and processing of data? So it can be done on the edge of the network itself, or it can be do it in remote server, where we can able to analyze the data what you collected from the environment, and according to the analysis of the data, we can able to react. So what kind of reactions you want to make it? So when you're going to do a home automation, so if the temperature increase more than this 35 degrees centigrade, 25 degrees centigrade, it's easy, right? And if you felt that if you so nowadays there is a different sensors coming, even the neurology sensor is available. So sometimes if you feel that you want to watch a TV, so the sensor has to send your brain alpha beta gamma signals, and it has to be support, and it has to be communicated with the your processor, and it has to be communicated with the processor in such a way that it has to switch on the TV, but it has to switch on the TV immediately. So for do all these kind of reactions with respect to the environment changes, we need some storage and we need some processing of this data. And of course, the communication is going to play a vital role. So along with the challenges of this data collection and handling, there are the challenges in communication as well. So no one is not going to forget about that. And also the communications between IoT devices, mainly wireless, because they are generally installed at geographically dispersed locations, or we can able to say in the different locations. It's not going to be available in single locations to make it in a connection in the wire. So just we are just going with the wireless communications. So and also while going for a wireless communication, then we have to be very careful about our data losses. So whatever the data is going to be getting communicated from the transceiver to the receiver, it's supposed to receive it without any issues or without any what to say like fault conditions. Whatever the data is just sending from the transmit part, it has to receive it in the as it is without any losses in my data. So if there is a losses in my data, definitely we can able to get our required output what we're expecting from our IoT devices, right? So if you want to have such a kind of output, or if you want to make such kind of automation very perfectly from your IoT design, then we have to follow some set of architectures for the IoT. Okay, so we have to follow some set of architecture for the IoT. So there is no single consciousness of architecture is available. Like it's not going to be, it's not happening in single step. As like your previous slide, you understood that it's a collection of three major areas: sensors, actuators, storage, and data processing and communication. Right. So in order to execute this, okay, in order to sensor and actuators, and in order to go for the data processing and to go for communication, in order to execute these three important process, we need some basic architecture for that. And different architectures have been proposed by the different researchers. You may agree or not, by the year of 2020, there are 65 research network architectures that are proposed by the different researchers. Okay, there are 65, right? 65 network architectures are available for IoT because it's customizable. Anyone can able to customize architecture according to the application what they're going to execute. Or else, in other terms, if anybody wants to build their automation according to the applications, what they're going to consider, the architecture also can able to get differentiated. They can able to modify or they can able to customize. Right. So based on that, there are different architectures have been proposed by the different researchers. And here we are going to look out some conventional architecture, or else I can able to call this a basic platform of network architecture. By using this platform only, the 65 network architectures got developed in the year of 2020, up to the year of 2020. Whatever may be the new architecture will come into a market, or whatever may be the new architecture will be introduced by any kind of researchers, it will follow only the basics what you're going to study over here as early stage research. There are two types of architecture. One is 3-layer and next one is 5-layer architecture. You got the point, right? So whatever may be the different architectures getting introduced in the market is fully based on these two types, a 3-layer architecture and as well as a 5-layer architecture. And in the case of over here, when I say 3, when I say 5, when I say 6, when I say 7, and so on up to n layer of architecture, what this layer indicates? The layer numbers indicates over here about the depth and the finer aspects of IoT. If the layers keep on get increases, we can able to say that we are just doing a data in a fine-tuned method, and also we're going to get the output in a very better way. We're going to talk about these layers numbers, that is the depth and the finer aspects of IoT it's getting indicating over here, right? So based on that, let me go one by one. We'll start with the 3-layer architecture. So if you're going to talk about this 3-layer, it's having 3 layers called perception layer. It's going to be the bottom one, and we have network layer, and then we have an application layer, right? So this is going to be the first one we are going to be considered. The perception layer is going to be the first one, and second one is going to be the network layer, and third one we have an application layer. Let me go one by one how the perception layer is going to work out. Okay, so anyone can able to like you can guess what is going to be the perception layer? Anyone have any idea? Yeah, you can make it interactive, right? So no problem, right or wrong, no problem, right? So what do you may think about this perception layer? You just keep in your mind all the architectures, okay, like a 3-layer, 5-layer, 6-layer, even n layer of architecture. All these architecture layer is going to do, its layer is going to follow only 3 process. What was that? Sensor and actuators. What is the purpose of sensor and actuators? To collect the data from the environment, right? And then data processing and storage. What is the purpose? To do the data analysis. And also we need some space to store the data what you collected from the environment as like a lookup table. We can keep it over there. If 35 degrees centigrade happened, what I have to do the process? If 25 degrees Celsius happened, what I have to do with the AC? If 30 degrees happened, what I have to do with the AC? So we have a collection of data. It's got processed, and we're just keeping a lookup table. That is called the data processing and data storage. And finally, what we're going to keep it in your final steps is going to be communication. What does the communications means? Just communicating with the physical environment again. It can be any kind of actions. What does it want to make it? It can be switching AC. It can be switching the TV. It can be switching your fan, right? So it can be that again. It's going to be communicating with the physical environment to do some activity based on the data what you collected and as well as what your data is processed. So based on these three factors only, all n number of layer architectures got proposed in the market. So based on that only, we just seeing about this 3-layer architecture. It's starting with perception, network, and as well as the application. Okay, so this is the background. If anyone can able to predict what is going to be this perception layer, I said perception layer is the initial one, and then network layer, and then the application layer. So what do you think about this perception layer? Any idea, anyone? Right or wrong, no problem. Here we are to be in the same platform to discuss what happening in IoT, right? So it's no matter that it's right or wrong. Like, what do you think about this perception layer, or what is it going to be happening in the perception layer? Whether the data processing is going to be happen, or data collection is going to be happen, or communication is going to be happen. What do you think about? Yes. No one want to talk about that. Okay. So what is a perception layer is indicates it's a physical layer, right? Which has a sensor for sensing and gathering the information
Sir,
about the area.
sir, sorry to disturb you.
Yes, ma'am.
Kalpana ma'am has posted one question. Sensors will be there.
Yeah, okay, madam. Ma'am, actually, if any questions get posted, could you please guide me, madam, because I'm just
Yes, sir.
concentrating. Yes,
That's
yes.
what I'm following her, sir.
Okay,
Kalpana ma'am, you can raise your hand and put the question to sir directly.
okay.
Okay. No, ma'am. Sir was asking about perception layer, so that I said sensors will be
Good.
there to collect the information
Correct.
from the environment.
Thank you,
Okay.
madam. Thank you for
Thank you so
your
much.
answer.
Okay.
That's a very perfect one. That's a very perfect one. What Kalpana ma'am said over here. It's a physical layer which has a sensors and actuators for sensing and gathering information about the environment, right? And it sends from the physical parameters and identifies the other smart objects in the environment. So all this kind of going to happens in the perception layer. So we used to call the sensor and actuators will be fit in the perception layer. That's very good to say. It's just nicely said by Professor Kalpana. And next we have that network layer. So where is responsible for connecting to other smart things, network devices and servers, and it just futures are also used by transmitting and processing some sensor data. That's what I said to you know initially. Sensor and actuators, after that we have data storage and data processing, that happening by means of using this network layer. And what is the application layer again? You make it identify what is this application layer is going to be. It's going to be take part of in communication. So it's responsible for delivering an application. Okay, it is responsible for delivering an application according to what? According to the sense data what we got from the perception. Okay, according to the sense data what we got from perception. And here we are doing a processing. Okay, here we are doing a processing. And now process data is going to be given to the application layer, so that now the application layer will take responsible for delivering application specific services to the users. Okay, it defines various applications in which the IoT can be deployed, For example, like your smart home or smart city or smart health, what else? And smart waste management, smart water management, smart library, smart teaching learning process, what you're doing now presently, right? So here when I say that sensor over here, what is the sensor over here? The sensor over here is nothing my writing pen. It's my pen, right? My writing pen. I'm writing here. So what I'm writing in this slide over here, you're getting it to an end. How it is happening? So here my sensor pad is going to be collecting my data from my pen, and by using the perception layer, and I'm just using some network layer over here. Here my network layer is nothing but my local IP here, internet protocol. It's connected with the server. It's just collecting my data. It's doing all kind of process, and it's just get broadcasted to the cloud. Right from the cloud, you're going to be get obtaining my APT or obtaining my write of what I'm just doing in the slide over here at your end. Right. So that is the things that's happening in your three layers structures, right? So that is going to be a three-layer network structure over here. So when you say this, how should we make a second? Good. It's just disturbing my, this screen is disturbing my, so I'm doing some setting. All right. Good. Okay. So when I say this three-layer architecture, so in the three-layer defines the main ideas about IoT. So no one is not going to be say no, but it's not going to be sufficient, right? It's not going to be sufficient for the if you want to get into the research of your IoT in deep, it's not going to be more sufficient, because it's often the research will be often focuses on the finer aspects of IoT. Like we have to be make it to be more clear about how come the data is going to be getting collected from the sensor and actuator, what type of sensor we're going to use it, and also we are going to what type of data we're going to be collected, how we're going to process it, how we're going to be store it especially, and how come, what are the different types of techniques we're going to adopt to go for the data processing, and what are the different types of techniques we're going to process to go for a communication. So like that, we need some elaborations on your network architecture. So conventionally, they came up with a three-layer architecture, and they found that if you want to go for research work in the IoT area further, so this three-layer is not going to be enough. So we must make sure that the layer has to be get increased so that we can able to fine tune how come the data process and as well as data storage and as well as the communication side, we can able to give some more exact picture in terms of the IoT research. So the limitation is going to be need more focuses on the aspects of IoT, and expecting many more layer architectures we are requiring, and they need improvements in the data processing, and we have to be very particular, especially data processing, what type of data processing, how the data processing, where to do the data processing. So everything has to be more important. And then the communication protocol is also going to be another one important criteria, because we are dealing with wireless communication. So what type of communications you want to make it? Let's say, for example, do you want to go for any wireless, or do you want to go for any Bluetooth, like you want to go for a Zigbee, or you want to go for a NFC, right? So like a near field communication, or do you want to go for any Wi-Fi communications, like that? We have described the protocols in many in a better way. So for the purpose, we have to increase the layers. What is it existing in the architecture, right? So the best solution is going to be a five-layer architecture. That's what we're going to be look out in the next slide. We're going to talk about the five-layer architecture. So when you're going to look at this five-layer architecture, we already studied about this perception layer. We already studied about this perception layer. Okay, let me take a. So we already went through what is the perception layer. So where we will have sensor and actuators to collect all the data. And also here, we already just went through what is the application layer. But in between this perception and application, you can even found there are three more layers got introduced over here. One is transport, one is processing layer, and next one is nothing but is going to be the business layer over here. So this is five layers of the perception, transport, processing, application, business. So here the role of perception application is already same as like what we just discussed in your three-layer architecture. So what is the transport layer indicates over here? So what is the transport layer is going to be getting indicating in this particular structure. So here the transport layer will transfer the data, and it's, or else we can able to say that it's just going to provide a protocol or the rules in such a way that the way in which we can able to transfer the sensor data from the perception layer to the processing layer, and also vice versa we can do to the network such as wireless, especially we can able to say like just now what I said to you, by using any 3G or by using any LAN network or Bluetooth or RFID or any near field communication like NFC technique. So we can adopt any kind of techniques by this, so that we can able to transfer the data from the sensor to the processing layer by using this transport layer. Right. So in the previous case, we are not going to discuss about the what is the way in which it's going to be getting communicated, and what is the way in which it's going to be getting transferring the data. Simply we said perception layer. Yes, that's all. But here we are going to be particularly we are going to define a layer separately for transport, so which will deal with the transports of the data between the sensor and to the processing layer by adopting some communication aspects what we have in the market. And then what is processing layer is indicates over here. So now everybody can able to understand what processing will be happen. So we're going to do some data processing. On other terms, or technically we used to say that we're going to make use of some middleware layer. We always, the other name of your processing layer can also be given by name is a middleware layer. So what is this middleware layer do? It stores the data, it will analyze, it will process the huge amount of data that come from the transport. That is the main operation or the main function of a middleware layer. And also it can manage and provide a diverse set of services to lower layers. And also it employs many technologies such as database, cloud computing especially, and big data processing can be done by using this middleware. So that is the advantages why we are going to have a middleware layer or the processing layer between the transport as well as the application layer. And what about your business layer does? The business layer will manages the IoTs, the whole IoT system, right? The business layer over here is going to be managing the whole IoT systems, including what? Applications and business and profit models and users privacy, and also the business layer is out of the scope, out of the scope where we can able to have what to say like the total complete management of the IoT system what you're getting developing can be adopted by using this business layer, and especially we're going to have piracy on the application what you're going to be get developed, so that the no intruders cannot to be get into the system. That is very important, right? So the no intruders will be get into the system to be they can't able to hack your IoT device what you got developed. So no the third person cannot be controlled. So it's going to provide a proper piracy and privacy for the developers. And that is the reason why we have to go for this a 5-layer architecture, right? So we see 3-layer, and then just moved on to 5-layer. When we compare it to 3-layer, here in the 5-layer we have 3 important factors we introduced. One is a transport, and one is a processing where it's going to adopting the middleware, and finally we have business layer to provide some privacy as well as the security for the IoT what we're getting developing. Okay. So when I say this data process, again we are using the word called data process. So where we can do this data process. So if you want to do such a big data, when you're going to apply this IoT to develop or to be control a large application, then we have to be what to say like we have to be have a huge amount of space where the data has to be collected and to do some data process. So in order to do such kind of a huge amount of spaces, we can able to go for some cloud architecture, cloud kind of architecture. In particular, we have been slightly uncertainly about the nature of data generated by IoT devices. So we need some space. So that's going to be the cloud. We can able to make use of this cloud computing. That's going to be giving a primacy because it provides great flexibility and as well as the scalability for us actually. So we can make use of the cloud computers so that we can able to do the process of the data, and then we can store it back to the cloud. And whenever we need the data, we can able to get it back from your cloud computing. So that is a very important future about this cloud architecture. So it offers services such as core infrastructure, platform, and software storage especially. right? The developers can provide their storage tools, software tools, data mining, and machine learning tools and visualization tools through this cloud computing. Especially today, after we're going to see one of the sessions that's going to be artificial intelligence or IoT, I believe so, by afternoon session. So that will deal with the how come these machine learning tools can able to be do it in the cloud architecture so that they can able to provide a perfect data processing for your data what you're going to collect from your IoT device, right? So there is another one important or another one the basic conventional architecture what we found it's called a fog architecture over here. So there are moved towards architecture of fog computing. So where the sensor network gateways do a part of the data processing and analysis. And especially this fog architecture presents a layered approach as shown in below what is it showing in the diagram. It just inserts monitoring, pre-processing, right? It was just given circle over here. These are the new techniques what is got introduced between your physical layer as well as to the transport layer over here, right? This is between your physical and transport layer. We just introducing a monitor, pre-processing, storage, and as well as the security layer as the middle layers between your uh, physical layer and as well as the transport. So let me see one by one what is about this monitoring layer. The monitoring layer will monitors the power, resources, responses, and the services what you're getting from your data. And when you talk about this pre-processing layer, it performs filtering, processing, and analytics of your sensor data, right? Whatever data we're going to get it over there, and the data analysis can be done by means of using this pre-processing layer. And what about the storage layer, or in other terms, we can use to call it the temporary storage layer. In other terms, we can use to say it's going to be temporary storage layer. Okay. So the temporary storage layer is provides the storage functionalities such as data replication, distribution, and data storage can be done by means of using this temporary storage layer. And then finally we have a security layer over here. So it performs the encryption, decryption, what I said to you in the previous state. For the business layer, we've seen that, right? That got modified as a security layer over here in the fog architecture. So where it's going to do some encryption, decryption, so to ensure the data integrity as well as the privacy, so that the intruders cannot be get into the system design or to get into the system functionality what you got designed over here. So for the purpose, we're going to make use of this security layer. And then the monitoring pre-processing are done on the edge of the network before sending the data to the cloud, right? So the monitoring pre-processing has to be taken care about again before sending the data to the cloud architecture. So that is very important about this fog architecture, right? So when you're going to look at the previous architecture, it's nothing is going to be getting differentiated. So we are using the same layers again and again, starting from your pre-layer. You're just using the same. This is the basics: perception, network, and application. Using these basics of this, what we did now we just modified the network into elaborated the network into what? A three more layers over here as a transport, processing, application, right? And then business layer over here. The business layer is for the what? The protection or privacy purpose. So again, this file architecture is going to get modified in the fog layer architecture. So that's what we are seeing over here in the fog layer architecture by just modifying as monitoring, pre-processing, storage layer, and as well as the security layer, right? So sometimes when we used to hear this fog computing can also be, and often terms of fog computing, edge computing are used interchangeably many times. So when I say fog computing, originally termed by the Cisco peoples, the Cisco refer to the smart gateways and smart sensors. So for the purpose, they given the word called fog computing. Whereas in edge computing is slightly more preventive in the nature. When you compare with the fog computing, the edge computing will be slightly more preventive in the nature. So this paradigm envisions adding smart data pre-processing capabilities to physical devices such as motor, pumps, lights, so that from there we can able to get to collect the data that can be more precisely done by means of using this kind of the edge computing process or the fog computing process. And aim is to do much processing of data possible in these devices which are termed to be at edge of the network. And in terms of the system architecture, the architecture diagram is not appropriately different from the your existing. It's going to follow the same kind of existing structure, but only thing we're going to change the malware functionality. Right, only thing we're going to change only the malware layer. What is the malware layer here? That is nothing but a pre-processing layer. What is it available here, right? So we're going to do changes only in the malware layer structure. So that is going to provide a drastic difference between a 3-layer, 5-layer to the form layer architecture. So finally, the distinction between the protocol architecture and system architecture is not going to be very crisp. So it's going to be follow same kind of structure. So we can use the same 5-layer IT IoT protocol here also in the fog computing, but only thing it's going to be very over here. One is the malware functionality, and second one is the cloud computing. Okay, so the difference between your 5-layer network architecture and your fog architecture is nothing but only two. That is nothing but one is your malware architecture, right? Malware layer changes, and second difference is going to be that your cloud computing. So only these two changes going to be happen for your happening in your fog computing or edge computing process. You see that? That's what you can able to understand now. So from starting from the 3-layer, they're just modifying one by one slightly by means of introducing some new layer inside between your perception and universal application for transport separately, for data processing separately, for cloud computing separately, and then for network communication separately, right? And for privacy separately. So they are introducing layer by layer with the base of your 3-layer structure, so that we should not forget. Okay. So we've seen three, right? So far we've seen three-layer architecture, and then 5-layer architecture, and then we've seen about fog architecture, right? So now we are going to talk about the next architecture is called SIoT architecture. You know, this is the architecture which was developed by the year of 2018. Okay, by the year of 2018, they come up with the SIoT architecture, that is nothing but a social IoT. That is nothing but the social IoT. Right. So it's a new architecture that's got developed in the year of 2018. So here we consider the social relationships between the objects the same way as like what human from social relationship, right? So how the human is going to having a social relationship, in the same way they just adopted the in and around human relationship, how it is going to be having a relationship with the social. The same kind of activity is going to be happen in your SIO in your IoT architecture. That is called social IoT architecture. So here there are three main features of SIoT. What is that? Three main features. One is like here the SIoT is navigatable. SIoT is a navigatable. You can see the first primary feature of your SIoT is nothing but it's a navigatable. So what is a navigatable? That means like we can start with one device. Okay, we can start with the first device. We can start with one device, right? We can start with one device and to navigate throughout all the devices that are connected to you, right? We start with the one device, so that will navigate us. Let's say for example, this can be device 1. What you connected with your IoT can be device 2. It can be device 3. So like that, we can able to have n number of devices. There will be n number of devices will be connected together on a single IoT platform. So what I said, it's going to be navigatable. If you connect a device 1, it will navigate you to the device 2, and the device 2 will navigate to device 3, and so on. You can able to navigate up to the n number of devices. What is it connected with your device? What you connected with your IoT? Like that is why we are just calling as SIoT architecture is very navigatable, and also you can able to it just replicating the social relationship between one device to the another devices. Okay, it shows the social relationship between the one devices to the another devices, and also it is very easy to discover a new devices and services using such social network IoT devices. Why? Because it's just navigating one by one, so that we can able to easily discover is there any new devices getting added along with your IoT immediately according to the application, that can be easily identified because of the navigation process, what happening in your SIoT architecture. Okay. And next property of your SIoT architecture is going to be it's a need of trustworthiness. What do you mean by trustworthiness? It's a strength of the relationship, right? It's present between the device, okay, it's present between the device as well as to the data. How trustworthy it is? If I say if I have one temperature sensor, it is sensing the temperature value is going to be 25 degrees centigrade or 26 degrees centigrade from the environment. So how come? What is the trustworthiness, or what is the is it actually 25 degree? Is it actually 26 degree? That trustworthiness has to be ensured that in your SIoT architecture. Like similarly, how the friends on the Facebook, they have trustworthiness between them, right? So based on that, here also the devices and as well as the data processing will have some trustworthiness behavior in your SIoT architecture. And third future of your SIoT architecture is nothing but we can use models similar to the study human social network to also study the social networks of your IoT devices. So these are all some peculiar features about your SIoT architectures. What is it available in your IoT? It's a newly one introduced in the year of 2018. So what are all the SIoT basic components? Okay, if that is the SIoT architecture, then we should know what are the SIoT basic components are available, because it's going to be navigatable. Am I correct? It will having some trustworthiness, and it's just going to do processing of the data in a very crispy way. So in order to do such kind of activity, or in order to attain such a future from the SIoT architecture, we need some basic components. What are all the basic components? Let's say, for example, it's like ID. Like each and every device must have one ID, right? What is ID? Is nothing but identification. Each and every device, what you're connecting with your IoT, should have some ID. So we need a unique method of object identification. An ID can be assigned to each and every object what you're going to be connecting with your IoT devices. So the ID can be, we can able to ask like your MAC ID, while you're using your computers, we may have a MAC ID, right? So like a MAC ID, and then for internet protocol, IPv6 ID we may have, right? IPv6 ID we may have. So such kind of universal product code or the customized ID has to be given for all your devices. What is it connected with your SIoT? So that is the first basic components of your SIoT architecture. And what is second SIoT? What is the second component of your SIoT? That is nothing but a meta information. That is nothing but a meta information. Yeah, along with an ID, we need some meta information about the device. What is meta information will describe as the device that describes as what? It is in the form of what is its operation and what is its form. What type of the data form, whether the data what it's collecting, what type of formalities available in the data form, right? Data form. Whether you are collecting the data is a digital data, or whether collecting the data is going to be analog data, in what form the data is available, whether it is available in digital form, whether it is available in analog form, right? And if it is a digital in the sense whether it is going to be signed data or it's going to be unsigned data. Am I correct? So like that we can able to differentiate. We can able to get an ideology about the form, what form the data is available, and as well as what operation is going to be. That is going to be deals with the meta information. And this is required to establish the appropriate relationship with the device and also the appropriate place in the universe of your IoT device. So that is the need of your meta information. That is the need of your meta information. And third one, we are going to talk about the security controls. The third basic components of your SIoT is nothing but the security controls. So this is similar to your friend list. Okay, this is similar to your friend list settings on your Facebook. An owner of the device might place restrictions on the kind of devices that can connect to it, right? Like your friends limitations can available Facebook. You can able to control it. So whom you want to become a friendship with you, and to whom you can able to chat with you, or to whom you can able to share the message with you, right? So like that, you may have some controls on the Facebook, right? The same kind of controls are available over here with the devices also in your connected in your n number of devices what you connected to the IoT, right? The devices also will have some controls over here. Which device can able to communicate, which device should not get communicate. So that kind of controls can be get provided by means of using this SIoT basic component. And then we have service discovery. The fourth component is going to be the service discovery. So here it deals with like a service cloud where we need to have a dedicated directories that can store the data, details also store the data, and providing the certain time information to the IoT devices. And it's going to become very important to keep such kind of a large number of data. Right? So that's called your service discovery, where it's going to be storing the data in a better way. And then we have relationship management. Okay, so this is one of the module which manages the relations with the other devices. Like it also stores the types of devices that that given device should try to connect with based on our type of service provided, what is available in your device, what is available in your IoT. Let's say, for example, it makes sense of light controller to make the relationship with the light sensor. Did you got the point? That means a light controller, a light controller, a light controller can be a IC, right? The light controller can able to have a relationship with what? Light sensor. Okay, it will have a relationship with the light sensor right there. And then we may have service composition over here as a final module over here. So this model takes a social IoT model into the new level. The ultimate goal of such a model to have it over here, that the system is to provide better integrated service to the users, right? For the better integration. Service composition is just adopted for the better integration. For the better integration of operation, we're going to make use of this service composition, right? Right. So just we see a different architectures starting from 3-layer, 5-layer, farm architecture, and then we were discussed about this SIoT, social Internet of Things architecture. Okay, but if you look at very closely again, the new element over here is nothing but this ID and meta information and social security control. This all looks like a new thing, but the service discovery and relationship management service composition that is already available in your 5-layer architecture itself and farm architecture itself actually, right? So like that, we can able to introduce a new elements and new layers, so which can able to support the basic 3 process again, sensor and actuators and the data process and then the application, right? That's all. So that is the way in which your network architecture is going to get developed. Now, if you might look at in detail, or if you might look at any kind of IoT device which is developed in the market, okay, if you might look at any IoT device which is got developed in the market, it's going to adapt 5 basic parameters. What are they? One is the perception, and second one is pre-processing, and third one is communication, and fourth one is middleware, and fifth one is application. By following this cycle only, we can able to come up with a complete IoT design, right? One has to start with the perception and pre-processing, communication, middleware, and then application, right? So perception again, it's going to be indicating as the sensor and actuator, and pre-processing is indicating that how you're going to store the data, how you're going to do the process of the data, and communication will define as that how we're going to get communicated with the environment. And middleware will indicating that what type of format you're going to follow to have a communication with the environment. An application is directly dealing with the environment, where the physical environment is going to be getting controlled by the physical input what we collected from the perception over here. So without these 5 steps, we can't able to go for IoT design. Right? We can't able to go for an IoT design. Am I correct? So we are starting with the collection of data. Is the most important for the IoT, and there are various types of sensor used in your diverse IoT applications. That is indicated over here. There are various types of sensors going to be available in your market or the environment that can able to provide the data for us to store to collecting the data from your physical environment. Right? Am I correct? So that the most generic sensor available today, even in the smartphones, especially the smartphones itself have many sensors. Am I correct? In your smartphone itself, there will be many sensors embedded in it. Actually, like a location sensor available called GPS, movement sensor are available. Am I correct? Like accelerometers and gyroscopes, and camera sensor is available, light sensor is available, microphone, proximity sensor, what else? And magnetometer sensor. So these are all the different sensors available even what you're holding in your home, what you're holding in your hand, smartphone, that's carrying it actually. There are many other types of sensors also like beginning to be used, such as sensors for measuring temperature, pressure, humidity, medical parameters of the body, chemical and biochemical substances, and some neural signals. So there is a number of sensors available over here to make to identify or to be get the data from the environment. Right. Subsequently, we have to discuss about the data processing also. Plus such applications like mainly filtering and summarizing the data processing before sending the network. Such typically the little amount of temporary storage data has to be taken out over here for the operations, right? So based on that, we are just going to make use of this perception. So we're going to make use of this perception and as well as the pre-processing. So we are carrying out the perception and as well as we're just going for this pre-processing over here, right? So let me get into each and every layers one by one so that we can able to easily understand. We will see individually how individually it's going to be getting acting it. So let me see the basic components of the taxonomy one by one, starting from perception and then pre-processing, and then we can go for communication, middleware, and application. Right. So far, before getting into the components of your taxonomy, okay, before getting into the taxonomies of your IoT or the classification of IoTs, anybody have any doubts on the topics what we had discussion so far? Yes. Shall I proceed? Okay, I'm just taking your silence as I'm just proceeding it, and just keep your questions. If you have questions with you, keep your questions and just put back to me while we're completing this session. Okay, so we are going to get into a description of each and every 5 steps what we see in the taxonomy. So starting from perception, that is called sensors and actuators, and then we are going to discuss about the pre-processing, and then communication, then middleware, then we will go for application. So that is the way in which we're going to describe the total network architecture, and we're going to see the functionality of the total network architecture. Fine. So with that, we'll start with this. You start with the sensors and actuators, especially we are going to see in sensor and actuators in all IoT applications need to have one or more sensor will be available for what purpose to collect the data from the environment. And also we know that sensor is going to be more essential components for the smart objects, right? So one of the most important aspects of your Internet of Things is going to be the context awareness, I believe. So you will also agree that. Am I correct? So one of the very most important aspect of IoT is going to be a context awareness. The IoT must have the awareness about the context, what is it happening in and around it. So it is not possible without the sensor technology. Am I right? It is not going to be possible without this sensor and actuators technology. So that IoT sensor is mostly in small size and have a low cost. Always we just used to prefer the IoT sensors when we're going to use to prefer as IoT sensor or the actuators, whatever it might be, right? So it's going to be that it's very small size, mostly in a small size. We're just expecting that mostly should be in small size and it should be have a low cost. That's what our expectation. It should be low cost, and then it's going to be power must be very, very less. Power consumption of your sensor actuator must be very, very less. So that's what we are expecting it at. Am I correct? So based on that, there are developed, there are many a number of sensor and actuators that developed in the market. Okay, fine. So we are going to look about these different sensor and actuators. But before that, what do you think about the sensor and actuator? What do you mean by sensor and what do you mean actuator? What is the difference between these two? It's a basic thing, right? What is sensor? What do you mean by sensor in general? What do you think about the sensor? Even you can unmute it, no need to type it. You can even unmute it and speak with me, no problem. What do you mean by this sensor you think? Or what do you mean by actuators? What is the difference between these two? It's a basic question, right? Everybody knows as a teacher. Yes? Because we're going to deal with the n number of sensors and its operations. Yes? Can I have some response? Sensor? Okay, even you can type it. Yes, yeah.
Yeah.
Yes, ma'am.
Sensors
ma'am.
are like our eyes, tongue, everything. It used to sense the environment, and
Mhm.
actuators are like motors to perform any operation. After sensing, we need to perform some operation. So
Okay.
actuators are for that, and sensors used to sense the environment.
Okay, okay. Very good, very good. Thank you, thank you. Again, in your statement, we're using this word called sensing actually. So we are into a defining of sensing only here. So that's a very good one. Any other view you have about sensor and actuator? What is sensor and what is actuator? Because we are using the word sensing again, so we should not use it. So sensing. So we are just trying to define what do you mean by sensing actually. What do you mean by sensing is happening? What do you mean by sensing? That's the question. Yes. Sensor is a device which convert what? Any physical quantity into what? Into, am I correct? The sensor is a device which can able to convert any physical quantity into electrical quantity, right? It can be a temperature sensor, it can be a what to say like it can be a chemical sensor. That energy may be in any form. The physical quantity can be in any form. It can be electrical, it can be electrical, it can be what to say like it can be chemical, it can be neurosignal, whatever may be the physical quantity. It will convert into electrical quantity, or it will convert into electrical signal. That is going to be that sensor does. Then what about actuators then? How come actuators differs from the sensor? What madam said that is correct actually. What is actuators differs from the sensor actually? The sensor in that, what is actuators do? Actuators is nothing but like actuators will be the other form. Even the actuators can also be called it as a transducer. The actuators can also be called as a transducer. So the actuator will have a capable to be operate as a sensor as well as transducer. Okay, in other terms, then what is transducer means actually? Transducer is nothing but it can be convert any form of one form of energy to another form of energy. It can convert one form of energy to the another form of energy, right? Even it can be electrical to physical, physical to electrical. You got the point? The transducer can able to convert your electrical to physical as well as physical to electrical. Both is possible. But in the case of sensor, it's not possible to convert from physical to electrical. It will always convert physical to the electrical only. Okay, so based on the concept, we are just going to categorizing the sensor and actuators in different category. One is a mobile phone based sensors. You know, like what are the mobile phone based sensors are available. So you're going to tell one by one. I'm going to make a note in my slide over here. Then medical sensor we have, then neural sensors we have, then environmental chemical sensors are available. And nowadays, you know, like all of you, those who have a car and those who have a, and also those who are reading the newspapers, you may aware about that. Nowadays, we must FASTag is going to be very important element if you want to cross a toll gate, and FASTag is going to be done, or FASTag is implemented by the technology called RFID, right? But the RFID is also going to be acting as another one important sensor over here, right? So now I have a now I can get some quick input from the audience. Can I able to list out what are the mobile phone based sensors available? Just now we seen what are the sensors available in your mobile phone? Can you list it out? Anyone? Yes. Let I make a note. Point number one is what are the mobile phone sensors available in your mobile phone? You have your smartphone with you, right? I believe how many of you are attending the program with the smartphone? You have smartphone with you now. So what are sensors available in the smartphone? Can you list it out? Yes. We'll start with the known things. We have a camera, right? Right? We have a camera, a microphone. We have a camera and microphone is available. Yes. And what about second one? GPS, right? Global positioning system, you're using it. And then we may have a light sensors. Are you agree that we have light sensor? Yes or no? Any contradiction? Do we have a light sensor in our mobile phone? Yes or no? Okay, there is some chat is happening over here. Chat. Light sensor, very good. We have a light sensor. Okay, I can even see the chat box also over here. Yeah, I can type it, no problem. We have light sensor is available. Anything else after light sensor with GPS, and we have a camera and microphone? Anything else we have? So we have proximity sensors. Am I right? We have proximity sensor will be available. Then we have a mechanical accelerometers are available over here for us. Accelerometer sensor is available. Okay, we have accelerometer sensor available. Then what else? Anything else I missed out in the mobile phone? We have gyroscopes, right? We may have a gyroscopes also, right? So all we know that this, then we may have a magnetometer, correct? I believe so. Magnetometer, I just missed out magnetometer data, magnetometer sensor, magneto. Okay, so these are all some set of sensors. What is it available? Yeah, fingerprint sensor. Very good, very good. So I'm just getting it. We have fingerprint sensor. Fingerprint sensor is available. Very good. So because nowadays we are just going for fingerprint authentication is going on, right? Good, good. So these are all some different sensor available, right? So what do you think about this? All these sensors are going to be getting adopted. Just these are the basic things which made the people to think about to go with the IoT. Right, that is made the things to that made the people to think about to go with the IoT to get developed. Right, and the same way we all know that there are some medical sensors available. Right, there are some medical sensors can be get also be available over here. So because there are many wearable sensing devices are available in the market, so they are equipped with the medical sensors. You know, right, and also like to be heart rate, pulse, to measure the heart rate. To measure the heart rate, we have. To measure the heart rate, we may have sensors, and to measure the blood pressure, right? We measure the blood pressure, we have a sensor. Nowadays, it's available in the market. And then to measure your body temperature, right? Nowadays, it's going to thermal gun. Thermal gun is available, right? To measure your body temperature, you may have a temperature sensor is available. And then to measure the respiratory rate, to just measure the respiratory rate, we have a sensors, and then we may have a blood glucose level to just measure your blood glucose level. We have a sensors, right? Right. And here I just shown one of the diagram over here. That is nothing but embedded skin patches, where we can able to see that it just looks like a patch that can be just stick on your skin just to be get analyzes. Do you know the things? What are all the elements are available in these patches? So there will be a different sensor available. Like even you can able to connect your EEG, and as well as to even you can able to take it over pulse rate can be easily taken out from this device, and also you can able to even the measure your blood pressure. Okay, you can even measure the blood pressure, what is happening in your body, that can get measured by means of using these embedded skin patches. So by adopting the technology called MEMS, you may hear it or not, I don't know, micro electromechanical system. So it's a combination of electronic device plus a mechanical equipment. Okay, combinedly we can able to fabricate along with your IC package, that is called MEMS, micro electromechanical system. By using that, just they made it is in the micron level to make the skin patch, so that will have incorporating with the different sensors like your pressure sensor, your blood pressure sensor, and as well as your EEG, such kind of sensors can able to be incorporated on a single patch. So by using that, we can able to even measure the data of your body condition. Right. So these are all the sensor which is available for your medical purposes. Right. And what about your environmental and chemical sensors? What do you know about the chemical sensors? You know, environmental sensors in the sense, what are the sensors we can call it as environmental sensors? What are the sensors we can call as environmental sensors? So what are the environmental sensors we know? Like it is nothing but temperature sensor. Yes, somebody is typing. Yes, of course, definitely that is very temperature sensor. Very good. Temperature sensor we have. Yes, gas sensor we have. Very good. I'm just getting the input. Good. Good. There is one more sensor, soil moisture sensor. Very good, very good. Soil moisture sensor we have, right? So, and then we may have a pressure sensor again. Okay, pressure sensor again. And then we have a humidity sensor we have, right? We have a humidity sensor, moisture sensor, pressure sensor, what we have. And then we may have water pollution, air pollution, right? Or water pollution sensor we may have, that also we can create. Then we may have air pollution sensor we may have, so where we can able to calculate how much air is getting, how much polluted is available in the air. Like what you're going to check with your cars, your automatic vehicles and bikes, you're going to check air pollution control. You're going to check your air pollutions, right? So air pollution sensor may be get available. So these are the sensors can be comes under the environmental sensors. And what about the chemical sensors? You think about that. What are the chemical sensors? Like in order to detect some chemical and as well as biochemical substances, right? In order to detect some chemical as well as some biochemical substances, we can able to make use of these chemical sensors. Especially all of you, I don't know how many of you are aware about enos. There is a technique called enos and this technique called e-tongue that are all available developed in the market, right? There are enos and e-tongue. It's available, or it just got developed in your market. So that and all is adopting this kind of a chemical sensors actually. What is enos does actually? So the enos and e-tongue may consist of a array of chemical sensors. It can consist of what? The array of chemical sensors coupled with the advanced pattern recognition. Coupled with the advanced pattern recognition. So based on the data, what is getting fed to the enos and e-tongue, so it can able to easily classify or segregate outcome it's going to be analyzed. Whether it is test, the test can be get analyzed. Whether it is going to be that a sour taste, or it's going to be very sweet or it's salty. So like that, we can able to even sense your the normal nose and tongue how we are doing it. So that can be done by means of using these chemical sensors, like by using enos and the e-tongue. Okay, fine. The same way, what I said to you that the RFID, right? RFID is also the another one important element which we are not avoidable by the sensing techniques. So the RFID is nothing but what? It's identification techniques in which we can able to even collect the data immediately. So what does it consist of this RFID? This RFID may consist of a small chip with the antenna. Okay, which may carries the data and which can read the data by the RF reader, RFID reader. So the tag will be transmit the data stored in the via radio waves. Okay, please understand the tag will be transmitting data stored in the it will be just data stored in the RFID will be get transferred to the radio waves, and it is similar to the barcode technology. It's almost similarly like a barcode technology. But what is the problem with the barcode technology? The barcode technology will always read the data in line, in sight actually, right? Am I correct? But the barcode technology always we just used to have your require line of sight communication. But in the RFID, there is no need of any line of sight communication. Okay, so based on the power, what is it available for the RFID tag? We can categorize the RFID into two types. One is active RFID, next one is a passive RFID. Okay, so based on the power distribution of your RFID, we can classify the RFID into two types. One is the active, one is passive. Right? If I'm going to say active, the active tags will be having a power source, and passive tags do not have any power source. Please be in mind. Okay, when I say the active and passive, so that always these active tags will have a power source and the passive tags do not have any power source. Okay, it have a power source, but the passive does not have any power source. So based on that power, what is it available for your RFID tag? They're categorizing as active and as well as the passive. Okay, so if you're going to ask the question now, how come the power can be attained by the passive tags? Then the passive tags can draw the power from where? It can draw the power from the electromagnetic waves which is emitted by the reader. Okay, it can be emitted by the reader and are thus cheap and have a long lifetime. That is the reason why the passive is not going to be having this your power source in it. So every RFID tag will have two things. One is transmitter one is reader. Okay, in your passive RFID tag, there is no power source is not available in your transmitter. It's available in the reader. The reader will just giving electromagnetic signal that can be get absorbed by the your passive RFID tag, so it can be get powered over there, right? So that is called your active and or passive RFID. And based on the antenna design, okay, so based on the antenna design, again the RFID tag can be classified into two types. That is nothing but a near field RFID. Next one is nothing but the far field RFID. Okay, based on the antenna variety, what they're using inside your devices, we can able to categorize as a near field RFID as well as the far field RFID. Okay, so the near field RFID will always use the dipole antenna. Okay, it's just going to use the dipole antenna, and the tag is also have a dipole antenna on the which in which an alternating potential difference appears. It's going to be getting powered up over there. Okay, so same way that based on the changes on your based on the changes on your antenna design, we can able to categorize this RFID into near as well as the far field. And especially if we're going to see the application where we can able to apply this RFID, we can apply in supply chain management, right? And as well as the access control, like wherever you go, the supermarket, or if you go for any kind of the cloth stores, where we can able to find these RFID tags over there. And for identity authentication, like in your ID tag, your ID card, like in our college, I have ID card over here. It's a RFID tag, because if you show my RFID tag, then only my cabin will be get open. Otherwise, my cabin will not be get open, right? So that's such kind of identification purpose we can make use of it. And then object tracking also we can able to make use of this kind of a RFID tag. So why we are going to study this kind of all varieties of sensors over here, just to be understand what are the sensor, what is it available in the market, which will be used for the perception layer. So next is going to pre-processing layer, right? So pre-processing, what I said to you, this is nothing but how we are going to process the data and where we're going to process the data, right? So especially I said if you want to process some data, we need a huge data storage space. So in order to do such kind of in order to make such a very big data storage, we are going to make use of a cloud data over here. We're going to make use of a cloud data storage where we can able to put the data inside the cloud, and we can do the process, and whenever you want the data back, we can get it back over here. So in order to meet such kind of things, we need some following. For what purpose we are going to do this kind of pre-processing? The one is for mobility, and then the reliability and real-time actuation, scalability, and as well as for the power constraints. So what do you mean mobility here? The most of the smart devices are mobile, right? It's going to be a mobile arts. It's going to be installed in the different locations. They're changing the location, make it difficult to communicate with the cloud data center because of changing the network conditions across the different locations. So that we have to take mobility as one of the constraints for the IoT application, especially for pre-processing. And then when I say the reliable real-time actuation, what is it? That is indicate the communicating with the cloud and getting back the response will take some time, communicating to the cloud storage, and again to take back the response, it will take some time. So that is indicated by the reliable and the real-time actuation. Then what is scalability is indicates more devices means more requests to the cloud, and thereby increasing the latency. So that the scalability also one of the important factor while you're designing the pre-processing stages. And then we have power constraints. What is power constraint is indicates the communication consumes a lot of power, right? And IoT devices are battery powered also, we know that. So they cannot afford to communicate all the times. So that we have to take care about the power constraints such a way that by introducing what to say, like unbatteried sources. Unbattered sources in the sense, what you can come to your mind, a solar panel. A solar panel based power can be given to all the devices, so that we can able to reduce such kind of power constraints. What is it available for your pre-processing, right? And then communication, there are communication challenges. There are a lot of communication challenges are available while you're going into a data communications between your environment to the data processed. So like addressing identification, low power communication, it has to be another one challenging issue for us. Then routing protocols we have to follow. Then high speed and non-lossy communication has to be taken out, and mobility of smart things also one of the important element to be considered to go for the communication challenges. When I say this addressing and identification, what is it? There is since we have millions of smart things will be connected to the internet. So they will have to be identified through a unique address, what we earlier discussed, like ID, right? It's by unique address on the basis of which they communicate with each other. So for this, we need some large addressing space and a unique address for the each smart object. So that's why we are just keeping this addressing and identification in the communication challenges. And when I say this low power communication, the communication of data between the device is power consuming task. That's what we discussed in the last slide. Especially the wireless communication will be support for this kind of low power communication. And also therefore we need a solution that facilitates communication with low power consumptions that have to be considered. So we have to be very careful while going to selecting the low power communication, wireless communication, low power wireless communication. You have to go with it while you're discussing. So here on the right side, I just listed some set of yeah, very standard and very popular leading communication technologies, what they're adopting in the IoT world, like IEEE 802 standard, low power Wi-Fi techniques, and then low power low pan technique, and then RFID techniques, and NFC is indicating near field communication. Okay, NFC is indicating the near field communication. Okay, and then Sigfox communications we have, right? And then LoRaWAN, that is also another one important popular communication methods. What is it available in the market now? LoRaWAN communication techniques over here. So in this the near field, what is the near field is indicates over here. The near field communication is nothing but a very short range wireless communication that we all know very thoroughly, like. So it's just through which mobile devices can interact with each other over a distance of few centimeters only, right? So all the types of data can be transferred between two NFC enabled devices in seconds by bringing them close to each other. So this technology is based on what RFID generally, and it uses variations in the magnetic field to communicate data between one device to the another device. But only one thing you keep in your mind, that can be communicated only in short centimeters distances actually. But in the IEEE standard, low power Wi-Fi and LoRa and all, it's just well equipedly developed in such a way that it's just providing a standard communication between one to another, right? So next component in our taxonomy is nothing but middleware. You may remember, right? You may remember the taxonomy. We started with the sensor and then pre-processing and then communication. Then it's going to be middleware. So what is this middleware? So the middleware, in the sense, the middleware abstracts the hardware and provides an application programming interface. Did you got it? Middleware is abstract the hardware, right? Right. Middleware will abstract the hardware. Okay, it will abstract the hardware and provides the application programming interface. Provides the application programming. Right. So we used to call API. We used to call as a API. That is the main job of your middleware has to be due. For what? For communication, for data management, for what purposes we are doing it? For communication and as well for data management. Okay, for data management and computation, security and privacy. For everything, we need such kind of a middleware kind of thing. So what are the challenges we have to do that? One is nothing but like it's going to be interoperability and programming abstractions are available. Then device discovery and management, again scalability, big data and analytics, and security and privacy, cloud services and context detection. So I just give you a small orientation about each and everything so that you may understand what is this interoperability and programming abstractions deals with. For facilitating collaboration and information exchanges, right? For facilitating the collaboration and information exchange between the heterogeneous devices, we need this interoperability and programming abstraction, because we may have n number of devices. We just seen that we may have device 1 to device Z. Each and every device will have a different methods of devices. It's not going to be unique. Device 1 is not going to be equal to device 2, because device 1 may be a DSP processor, device 2 may be another one sensor, device 3 may be a different types of sensor. Everything is going to be heterogeneous. Am I correct? So that it has to facilitate the collaboration and information exchange between the heterogeneous devices, and different types of things can be interact with each other. So for the purpose, we need this interoperability and programming abstraction in simple words. Then what is meanings of device discovery and management? So this is the future which enables the device to beware, enables the device to aware about all other devices which is in the neighborhood. And also the service provided by them can be easily identified by means of this device discovery management. It can be easily discover the nearby devices what are all available nearby me as a neighbor, right? So that can be done by means of using this device discovery management. Then what is the scalability deals with? Since it is IoT, we know that it's a large number of devices have to be expected to be communicating IoT setup. Am I correct? So that moreover, IoT applications need to scale due to ever increasing requirements. So this should be managed by some middleware. So that is the reason why we have to go for this scaling technique. Then big data and analytics will support us to go for data processing again. And security and privacy, we know that we have to provide a data security from the intruders. We have to go for the security and privacy, where we can able to provide a protect layer between the data from the cloud to the environment. And then cloud services, we are going to define that how effectively we are going to do the data processing in the cloud management. And then finally, we are going to have a context detection that will data collected from the sensor needs to be used to extract the context by applying the various type of algorithm. So for the purpose, we can able to go for this context detection actually. So these are all the some of the important challenges. What is it available in the middleware? And there are several classifications available in the middleware. One is going to be event based, service oriented, database oriented, then semantic, and as well as application specific middlewares are available. Okay, so event based in the sense like here we can able to all components interact with each other through things, right? That we know that. So each component will have a type of some parameters, right? So events are generated by, produced and received by the consumer. So based on the event, what type of event we want to execute, so we can able to even do the data process. That is called event based. Service oriented in the sense, if you have even n number of devices are connected, what type of services you want to provide. Let's say for example, when I say smart city, the smart city may consist of smart water management, smart transportation, like that. I may have a different smart library, like that. I may have a lot of smart devices will be get connected. What type of service you want to get distributed, or what type of service you want to get executed? So that can be done by means of service oriented. And database oriented will deals with what type of data you want to be get executed, or else what type of a previous data you want to be executed for the current application. So that can be a database oriented. And semantic and application specific deals with purely based on application what you're going to be execute on your devices over there, right? So that is called middleware, a classification of the middleware. So applications. So lastly, in your taxonomy, we have application, right? So we may have a sensor and actuator, and then pre-processing, and then communication, and then we have a malware, middleware, and then now we are going to dealing about the applications of your IoT. So in this case of this application of IoT, if I take your home automation, look at the diagram. If you say home automation, it may broadly classify into four. One is security and energy conservation and hassle-free lifestyle, and as well as the entertainment. When I say energy conservation, what are things will come actually? It may like your electrical energy savings, and some gas sensor to save your gas, right? And smoke sensors to detect your even any fire is going to happen or not. So like that. When I say this security, like definitely the security cameras will come into picture, right? And when I say the hassle-free lifestyle, where we can even have a smart TV, smart irrigation, smart locks and everything, and security smart locks going dealing with the security again over here, and the remote sensing is going to be providing for your hassle-free lifestyle. So in and around us, there is many number of applications are available, and based on the enormous number of sensors, what is it available in the market, and what we had a discussion in the previous slide, we can able to build a smart home automation or the smart city, or whatever smartness you want to make it for application, that is possible by using these sensor and actuators what we went through so far, right? So the best example here I just taken as a smart cities. So when I say smart transport, they may have a traffic surveillance and management applications, and applications to ensure the safety we have to do, intelligent parking management we have to be taken out, and smart traffic light has to be there, and accident detection application has to be taken care. If everything is going to get available, I can able to say that it having smart transport, right? Smart traffic surveillance. How we can able to make a traffic surveillance? How we can able to make a traffic surveillance? Simple. Everybody have a smartphone nowadays in your hand. Everybody have a smartphone available in your hand, right? So it's have accelerometers. It have accelerometer. So while you are moving in your vehicle, definitely the accelerometer will just provide me the direction of my XYZ, right? I may take my XYZ direction so that I can able to easily point out the movements of the traffic and as well as how heavily traffic is available. So that based on that I can able to do the management. An application of ensuring safetyness, so that can be done by means of using different sensors what we are adopting in the nowadays automobile vehicles, right? So again the gyroscopes and accelerometers will come into picture, and what they get installed in your vehicles or installed in your mobile phone, what is available. And magnetometer also will come into picture to go for the applications of ensuring safety. Intelligent parking management that can be done by the parking cameras, what is available in the car in nowadays over there. And also by using the RFID tag, we can able to easily measure, or we can able to easily indicate the parking space, what is it available, and even collision free and hassle free parking can be done by means of using this RFID tag. And smart traffic lights can be done by using based on the density of the traffic, what is it available in your road. Am I correct? And accident detection, again, your accelerometer is going to be coming to picture, and as well as your gyroscopes will be coming to picture to identify the accidents, and so that if any accidents occurs, we can easily intimate the accidents to the your nearby hospital. Am I correct? So that is a way in which we can able to come out with the smart cities, especially in the smart transport. So like that, there will be a lot of smartness will be there. Smart waste management, smart distribution of system, water distribution, smart learning, what you're doing now, right? Remotely. Then smart agriculture, health and fitness, supply chain, energy conservation. Water may be the smartness you want. That is the final conclusion. Water may be the smartness you want. You should have a proper network architecture. And every network architecture will have layers. And even though there will be a 50 layers, no problem. For assumption, for example, even though you may have 50 layers, what is the basics of the layers? Perception layer, and then perception layer is nothing but what? Sensor and actuator, and then data processing, and then finally it's going to be communication. You go 50 or you go 100 or even 200 or even 300 layers, but the basic operation is going to be the three: sensor and actuator, data collection, data processing and data storage, and then communication. So whatever be the number of layers, this is going to be get indicated. If you have this proper layer definition properly, and if you have a proper network architecture definitely, then we can able to achieve whatever the smartness you want to get introduced with this IoT. Okay. So when I go into for a design consideration for any IoT, if you want to develop a IoT device, or if you want to do some research work on the IoT, we should be consider the some set of factors. One is designing of sensors. What type of sensor, selection of sensors, or what type of sensor design you're going to do by your own, and what type of communication methodology you're going to adopt it. Wireless, wired communication, or wireless communication. If it is wireless communication, this is what type of wireless communication? Near field wireless communication, or IEEE standard wireless communication, LoRa wireless communication. What type of communication you want to make it? Which will be suitable? Which will be power consumption, right? Which will be have a fast operations to be store the data, to transfer the data. That you have to be designed. Then what type of middleware you're going to get applied? We just seen some challenges. So we have to be consider these challenges to construct middlewares, and we have to think about the application layers what we have. What type of applications you're going to execute it, and how the environmental conditions is going to get available. How come the data has to be processed based on the application? So these are all the basic considerations you have to be keep in your mind if you want to go with the IoT research. If you do your own IoT development, device development, then we should have these many constraints, and based on the constraints, I will have my network architecture, and based on the network architecture, I can able to come up with my own suitable IoT device. Okay. So as a synopsis for the for past 1.5 hour discussion, okay, simply because I just started off at 9:40, I believe by 9:15 my 1.5 hours will be get over. So I will be stick on my time. So as a synopsis, as a take home by this today's session, while you just talk about any kind of IoT design, we have to be design consideration is very very important element for designing and practical IoT network. And technologies in the core infrastructure layers are showing a sign of maturity, definitely, because just each and layer by layer we are increasing the maturity levels of your IoT devices, and lot more features in this area of IoT applications community technologies are available. You have to get explored, and just be little bit explored only a piece, okay, a fraction, okay. And then IoT mature and impact human life in inconceivable ways over the next decades. Definitely, in next 1 or 2 1 decade, IoT is going to be grab your total space. It's going to be done everything automatically. So we are learning many things, and today after we are going to learn about how the IoT can think individually by using artificial intelligence. I believe Dr. Pradeep is going to provide a session by today afternoon, and he is very well in the person to talk about this deep learning and especially the architect in the artificial intelligence. Like he may give an overview about it. Like so, where your IoT is going to take a decision. Okay, IoT is going to take a decision by itself. How the IoT is have to be performed. It will take automatically data can be get sensed. So it will have a data bank with them. It will be trained to take a decision actually. So I will conclude that we everybody enjoying this technology development. Okay, we are exclusively we are enjoying the technology development in a much better way. But these things you don't forget. Science is a good servant, but a bad master. So always keep these signs under you. Okay, and whatever the developments you've made, you just think that it should be a social relevant. You should consider the social aspects with you, and don't violate any social aspects. Don't create any such devices which can able to violate the social aspects. Like because we are all affected by this pandemic situation, but this pandemic situations were created by because of this science development. Please keep in mind. Somewhere in some lab, some science developments happen in the virus, right? So because of that, now we are suffering. The total world is being suffered. As an engineer, we can take an oath. We can keep the science development for the betterment of the future, not to destroy anything actually. So that's a point I would like to stress as a synopsis of my talk. And thank you for paying attention for my talk for the past 1.5 hours. And if you have any queries, you can keep forward to me. I'm very glad to answer your questions. Yes.
Thank you, sir, for your wonderful session.
Thank you, sir. Thank you.
So I request the participants to raise queries if you have anything. So kindly use the chat box to post your queries.
Yes, I'll open my chat box.
Sure, sir.
I'll open my chat box so that I can see the queries. Thank you. Explain wonderfully. Explain. Sir. Thank you. Okay. It's not matter like your query is worthable or not. Don't think like you can keep the query, no problem. Even if you have any doubts, no problem. You can keep it.
Participants can unmute yourself to raise your query and interact with our session chat.
Yeah, even I'm ready to interact with you because I can able to hear your voices.
So very informative and useful session, sir, by Saravana Kumar, sir.
Oh, thank you, thank you, thank you so much, Sarana Kumar sir. Thank you so much. Okay, even if you don't have any queries, you can post the queries to my email ID also. If you have this is my email ID. Dr. Arvindan at arvindan@university.in. This is my email ID. Okay, good. Then I have one question like, what is the minimum memory required for IoT and cloud? It's very very important question. Very good, very good. What is the minimum memory required for IoT and cloud actually? So again, sir, to answer your question, Dr. Piyush, sir, actually, to answer your question, that is depends on the application what is going to get developed. and depends on the data, how much you're going to get processed, like what type of application you're going to develop, and how many number of devices you're going to get connected, and how much you're going to be need the how much you're going to store the data. Do you have any storing the data process, or you're going to simply gather the data and then do process and to be executed? There's a two varieties are available: simply to gathering the data and do process and then execute the operation, or else we can gather the data, do the process, and we can keep it in the lookup table for the future purpose we're going to execute it. So that's what I said. How come, or what is that, how come you're going to be get implementing, and what type of technology, what type of application you are developing with the IoT, we can able to define the cloud storage amount we have, we can able to think about it. Okay. And next question, what I have one is, how can we link PLC SCADA with IoT? Okay, how can we link PLC SCADA with IoT? Vinay sir, I'm not familiar with this area, but I know about the network structures of IoT and everything, but I didn't work out with the PLC and SCADA. If possible, I will inquire and tell you. Vinay sir, actually. The linking between the SCADA, because SCADA is electrical, even though I'm basically I'm from electrical engineer, but I just left the electrical engineering division 15, 30 years before it's 15 to 30 years before it's I'm fully with the electronics now. So anyway, I just look into question. I will just get back to you. How come this IoT and PLC and SCADA can be get interconnected? Right.
So thank you, sir, for your wonderful session, and the session was more informative, sir. Thank you for accepting our invitation to.
Thank you. Thank you.
So I request, sir, one more question, sir, by
Yes.
Dr.
Is there any relation between memory and speed? Because here the data is stored in sequential mode. Yes, of course, Professor. There is no relation between the memory and speed. Okay, there is no relation between the memory and speed over here, especially with respect to IoT. Okay, why? Because we are just segregating the process into two mode. One is to data to store, and on the same time we are going to get execution over here. So there is no any absolutely there is no relation between the memory and speed, Professor.
So thank you, sir, for clarifying the query.
Okay, okay, sir. Okay.
So I request the participants to fill up the feedback form, which has been posted in the chat box. So I request all the participants to rejoin the session by 11:30. So we may have 10 minutes break as now. So I request the participants to rejoin the session 11:30.
Okay, I would like to attend the session of Dr. Pradeep, so I can join in the same link, right?
Yes, sure, sir. Thank you, sir. You are more
Yeah.
welcome, Mr. Wilkins.
Oh, okay. Thank you. Thank you.
The participants to rejoin in the same link by 11:30, followed by Pradeep sir's session. So kindly resume back by 11:30. Thank you.
So can I take a leave, sir?
Sir, sure, sir. Thank you, sir.
Yeah, I will join at 11:30. Thank you so much.
Thank
Thank
you.
you. And once again, thank you very much for Dr. Indra Devi, madam, to giving me such a wonderful opportunity to have interaction with such a teacher community. I am very happy to do that one. Thank you so much. Thank you so much. Thank you.
Thank you. Welcome, sir.
Yes.
So welcome you all for the second session. So today's session chair, Dr. C. Pradeep sir, visiting researcher, Smart City Research Center, IIIT Hyderabad. Sir has done his doctorate in VLSI design. He is highly skilled in EDA tools, hardware development tools, mentor graphics, front-end tools, etc. Sir holds more than 15 years of teaching experience, and he has published more than 33 research papers in conferences, national and international journals. Sir has worked as a professor and principal in Mar Beslo's College of Engineering and Technology, Kerala. He has also acted as the head of the department in St. Gitt's Center for Innovation and Entrepreneurship. He was also the associate professor of St. Gitt's College of Engineering. He holds the memberships and responsibilities as follows. Sir is also the member of IE, IETE, IEEE, ACM, IAENG, ISTE. He is the approved research supervisor of APJ Abdul Kalam Technological University, Kerala. He is also the reviewer of InterScience journals. Sir has organized more than 7 research programs, technical programs, and has also guided more than 12 MTech theses. So we are quite happy to have you, sir. Now the session is yours. Please take over, sir.
Yeah, thank you. Thank you very much for a nice introduction. I hope I'm audible to the participants, right?
Yes, sir, you're audible, sir.
Fine. So let me share my screen first and let us see how does it works.
So your screen is visible.
Yeah, I hope my screen is visible.
Yes, sir.
Once again, a wonderful morning to one and all. And let me, at the outset, convey my gratitude and thanks to Professor Dr. Indira for inviting me to have a session in this AICTE sponsored STTP. Then I think that it has been started a few days back, and all the participants have enjoyed listening to the very eminent speakers before me. I hope that all of you have now enough information about the what are the current developments in the field of IoT, and especially the topic is designed by using Raspberry Pi and Arduino. So I'm here to talk something related to that. Of course, definitely the topic of this session is given as artificial intelligence powered Internet of Things. So I think all of you, around 41 participants here, I think most of you are from the ECE and computer science background, and also I could understand that there are people from mechanical and also from civil engineering and other related branches of engineering. I think that my topic is not designed for a particular branch. It's for all that is disciplines of engineering. So I wanted to start with that. So as the the speaker that introduced me was telling about my background, and you can see that I'm a very hardcore VLSI guy, and that was till last August month 2020. So what I did, you know that as you all of have done the same. I think when our regular normal working has stopped by this COVID-19 pandemic, we tried to get some information or the learning experience by attending some of the online classes. So I also wanted to learn something because I have enough time at the moment. So I have done a search in the web, and I could find number of courses in more platforms like Coursera and NPTEL and other and university sites. You can see as usual, edX, etc. So most of the courses are actually belongs to the category of that is artificial intelligence, machine learning, and deep learning. So I thought, then I explored that why this much of courses have been introduced through online, and I just talked to a platform person that who does this kind of professional online courses, and he asked me around 2.8 lakhs of rupees for a 1-year course in artificial intelligence. I got wondered. So in the other side, I could see that number of free courses available in online, and these kind of online educators are asking big amount from the candidates, those who wanted to learn something. Definitely, by viewing the video or listening to somebody is not only give you the complete learning. Definitely you have to do something, then only you can learn. So I think that those platform or educators are providing those experiences, so I appreciate that, but the amount that we have to spend for that will be very big. So I started learning something from the web, and also thought of doing something and learn, right? So I explored an area which is not familiar to me, that is artificial intelligence. So I started from the beginning. I got the basics of machine learning. So I was not doing anything in this area previously. So I talked to my friends, and some of my friends and ex-colleagues have helped me a lot. Then I thought I would get some, I can do some, initiate some research in the area. So I got into the institution that is one of the lead researchers in India, where that is IIIT Hyderabad, where they have a smart city center established a few years back. So there, the work actually they're doing is it's kind of smart city related research. So I think that the previous speakers, especially in the last session, Dr. Arvindan, have talked about smart cities, I know. So you can see that one of the core areas of research, and everybody talked about in India and other countries, is that the how to convert the existing urban areas into a smart urban area. Because it is being predicted that by next 20 to 30 years, world's 70% of the population is to be or wanted to be live in cities. So you know that if the what is the situation currently in Indian cities, if you go to the Mumbai or Madras or Bangalore, you can see that to at least to cross a 1 kilometer of area in your taxi or in your private car, it takes hardly more than 2 hours, right? So can you imagine that another 40% of the population is also coming to the cities in coming 20 to 30 years? What will be the situation there, unless otherwise we have improved the supporting system of Indian cities at a large extent. So so I think that is why the government of India, and you can see that similar situation happening in other developing countries also. So because people believe that by living in city we can enjoy the more facilities. So that is why people want to migrate to the cities. So that is happening everywhere in the developing countries. So these kind of activities that you can see throughout in the developing countries, and India government have announced to convert the existing 100 cities into smart cities, and the project has been announced in the year 2015, and we have almost crossed 5 years. So the works is carried out in many institutions, many enterprises and government organizations. So that is, I was just telling that what is my background into this topic, especially artificial intelligence powered Internet of Things. So for the past 5 months, I'm working in some of the projects related to the IoT for smart cities. And my work is to bring intelligence to this process of IoT based services. So I just started with the introduction. So I think my job is a little bit easy now, because in the past sessions, I came into the session in the last few minutes. I heard that it was being discussed about a lot of applications, challenges of IoT networks and the sensor networks. So that is well connected with the topic that we are going to discuss today. So let me start with the overview of the presentation. So I thought of preparing a session for the intermediate kind of learners in that area, because those who understand artificial intelligence and IoT together, and in the little bit into the advanced level. But by talking to the Dr. Indira yesterday, I came to know that there are some participants in the program that they don't have any background in the programming or the artificial intelligence. So I included some of the slides to that. So so in this 1 hour 20 minutes, what I planned is to start with the introduction. So I can skip a little bit, because I think that some of the slides contains the information which is overlapped with the previous session. So in that, I think some of you can help me in that. And also, I wanted to tell you that I'm continuously, I will be talking. So I can't see any one of you. So I believe that my voice is reaching you. What all things I talk is it's audible to you. And I know that it's very hard to make you attentive in this throughout my session. So you know that even if I talk directly in front of you, it is very difficult to keep your attention more than 20 minutes. So, but in online session, the research have been done now, and people saying that a person can be attentive to an online session a maximum of 7 to 9 minutes. So I appreciate all the participants to be they came and joined for the second session. And I can see all of you here, and I believe that what of things I talk and that is reaching you. So if it is not happening, or if you are thinking that this is I'm crossing the border, you can to stop me at any time by raising your hand or chatting in the chat box. Fine. So we can straight away move on to the session. So these are the contents what I have planned to talk about. So the introduction part is already been, I think, talked by the previous speakers. Next, I will anyway. I'm going through that part in an artificial intelligence perspective. So the role of AI in IoT revolution will be talked. Then the impact of various segments, and something called AI OT is going to be explained a little bit more. And I included, as I told earlier, that the basics of ANN, because it is very much required for this session after that. So there are different challenges associated with that already being talked about, the challenges of IoT. So it is connected with that one. So the second part, I'm just going to show that one of the techniques that we used for incorporating artificial intelligence in IoT. So I'll be explaining that. It's not very tough, but it seems to be a little bit tough. But now you know that whatever difficulty we have, there is something to help us, right? Whatever things you want, you need to ask for the Google. In this case also, to overcome the challenges of AI and IoT, Google is there to help us. There is a product from the Google, so I will be introducing that. And if possible, if time permits, definitely we can see some of the demonstrations online, because I'm working on that. Some of the works I have involved, I can show that what I'm doing. And finally, coming to the conclusion, and that means the question and answer session. So I like more than talking one side to the other, but I like more interactive sessions. So if some of you are interested to speak or interested to know more about the research scopes in that area, I'll be happy to tell you that, because the talk will be mainly for the beginners and intermediate. So finally, if some of you are interested to explore the scope of the research, definitely I can really help you. So I'm expecting those interactions in the end if some of you are interested. So straight away, moving to the second slide. So I'm beginning from the point where Dr. Aravindan stopped. So you can see that this IoT mainly used for collecting data simply. Yeah, so you can see that the last 2 years, this is information, the 90% of the world data was created in last 2 years. Means the information, so the data we call about it is web-based informations. Wherever you do some kind of search or login or use some applications, automatically your all informations will be stored into the cloud. Then the second type of information of the data that we talked about is that we specifically put some IoT devices to collect the data. For example, I'm using a database, or traffic database from Caltrans University, California Technological University, where they have a database. They deployed more than 10,000 sensors from the year 2002 in all the roads of California state, and they started collecting the data. So in their server, in the cloud, they have billions of data stored, enough information. So now they are providing the data to the researchers free of cost. You can just go and ask them that I need to do a research, and they will provide the data to you. Similarly, but even in India, these kind of activities were started only when the smart city kind of initiative have begun. But even now, it is not being explored much. But there are some initiatives by the different state governments and other organizations and enterprises to deploy more sensors everywhere to collect the data, because you know that even we talked about the smart cities to bringing smartness to the every services. We need to do some kind of data analytics. We need to understand what is actually happening previously. Then only we can identify the gap and to do some additional kind of work and improve that kind of services. So if you don't have enough data, what we can do is it's a question. Now people have understand that the base of the kind of the intelligent kind of work that you can do is that it's a quality data base. Even but our country is a democratic country, and if you the question of the data or the collection of data comes, then definitely there will be the question of the privacy, and that will be a controversy there. But even though there are a lot of issues, but governments and organizations are putting a lot of effort for collecting the data. So for that, what is essential is that IoT devices, Internet of Things devices. So this diagram that you can see here actually which shows the entire process that is happening now. You can see that that the sensors are being deployed everywhere to collect information. Then you know that the 5G, now the 4G, we are on the 4G, the 5G is going to come. And 5G, using that, we can transfer this big data information into the cloud servers provided by Amazon or Microsoft or the other cloud service providers. So that will be stored there. Then coming to the question of the challenges. I think the previous session, the last part, you talked about that the challenges, because when you collect the data in every second, even fraction of a second, you need to transfer it to the storage where it will be located in a, that will be somewhere very far from the source of data. So you need a very higher bandwidth. And you cannot say that okay, all the informations are relevant for the further processing. So the data that you're collecting. So I think that topic also discussed that kind of pre-processing to be done for the collected data, and the reducing the size of the data and only limited to the relevant information, it will be passed to the cloud. So that a very what to say, that in the IoT domain, that kind of works is happening. And we can see that there are a lot of applications for this data, and that is shown and a separate area that data science is actually exploring much. It's that is, deep learning is actually playing a major role in providing solutions to the major issues in this segment. So I'm not going to deep into that one. So we can straight away move on to the next slide. And this is the diagram which shows that how this artificial intelligence and IoT can be considered together to find the solutions of some of the challenges and issues in this particular domain. You know that AI, now everybody talked about AI. Earlier, I also thought that AI is meant only for the computer science people, right? Later, I understood that, okay, ECE or other engineering branches also have some kind of work that can do in AI, artificial intelligence, even though we do that learn or image processing late. But now, in last 4 or 5 months, I understood that the other areas having much more applications, or they have more work to do with this artificial kind of intelligence. I can see that the civil engineers here, civil professors, they are extensively using the artificial intelligence to for the main that is a building science or smart room, then smart building, etc. And also for the mechanical engineers, they use this artificial intelligence for their smart industry, autonomous vehicle, etc., widely. Now everybody started learn artificial intelligence, even the IoT, the embedded system design and all. So it's going to be a kind of thing that intra-departmental technology thing to learn, right? So you can see that we haven't experienced the benefit of AI so far. What I talked about, what I'm telling this is that you know that you will be having some kind of AI experience in your mobile when you browse, when you use your Flipkart or Amazon. The next time you log in, you will get some product suggested for you that some kind of machine learning algorithms are working behind, and also to some kind of Netflix or suggesting some songs or YouTube videos. Some machine algorithms are working, but you know that it's not actually the basic requirement. But can you just look around and see that whether we are getting the benefit of AI? AI means nothing, but we are giving the artificial or intelligence to the machines or the supportive devices who can help humans. So whether can you go to your grocery shop or the vegetable shop and use your mobile to check the quality of the vegetable that you are buying? Not yet so far. Similarly, as I told earlier, that can you find some kind of applications there in your mobile or somewhere outside to find out the best way to avoid the traffic congestion? It is not it. Then again, if you still go to the hospitals, you can see that once you go to a hospital and give your all information, and then you go to the second hospital in another city, again you have to give your basic detail. But you know that all the doctors will be able to diagnose your disease only if you know about the previous history. But the hospital it's not at being, it is connected together. We talk about a lot of technology and IoT connectivity, 5G, etc., but it's not yet happened so far. And also think about the energy, the pricing you have to pay in your household, right? So what time you spend, normally in the morning and only in the evening there is peak load, the consumption is high, more people will be using that. And sometime in the noon or in the morning 11, the consumption will be very low. So but both the time you need to pay the same price for the unit that you consume. So I think in some countries that you can see that the dynamic pricing for the energy is already being implemented. So you can see that there are a lot of possibility for IoT and use of AI in that area. Then I don't know how many of you are concerned about the quality of the water that you drink. I don't know how the facility to drink Bisleri every day, but we always use the filter which is located in the institutions, right? So there are many types of filters, but the durability of those filters are very less. But sometimes those filtrations may degrade the performance of those filters. So the water quality is not being assured when you drink, right? So yeah, you have your mobile, but if there is any sensor available to check the quality of the water you drink, it's not yet happened. So there are some basic necessity for the peoples or the support the better living of people. So those problems are not yet being addressed by these even in this IT era. We talked a lot of things about the technology, IoT, artificial intelligence, etc. So this is actually going to happen in coming years. That I understood that by the convergence of combining these two hardcore technologies like IoT and AI, you can easily find out the solutions for some of the main issues. I can tell you that see, we find a solution for a calibration issue by using a simple linear regression algorithm in the machine learning. So when you have a sensor, I think you learned a lot of things about sensors earlier. So and when your time goes, there will be a lot of calibration issues for these IoT sensors. So replacing the sensor or manually calibrating, it is not very easy if you have billions of sensors deployed all around. So there should be some kind of that kind of smart calibration techniques to be adopted. So you can see that this machine learning small algorithms can do a wonderful job there to find a solution for you. So that is why I'm going to talk much more about how it can be done. So along with IoT, if you use artificial intelligence techniques, then definitely you can come up with some of the very good proposals and solutions for the society, which hardly requires. So now coming to the next slide. So I know that I'm taking much more time than I'm expected. So we started at 11:30. Then I will get time up to 1 o'clock. So I'll be speaking like this. If you want to interrupt me, no issues. Anytime you can interrupt and ask questions. So coming to the IoT revolution, this artificial intelligence is playing a major role. Now, just think about the data that you are collecting. So data can be used for these three main things. These are the which I have shown in this slide, that is predictive analysis. For example, if you want to forecast, if you want to avoid the traffic block, you are in the car and you will be known to the what will be the traffic at 5 p.m. in that particular junction. Definitely, if it is intimated at 4:30, you can find out some alternate path to reach the destination. You can avoid being stuck at the traffic block. So that is kind of forecasting, like dynamic prediction of the energy or the a lot of things can be done in the predictive analysis. The information is known to the people very early. Even we are doing a work to avoid the collision of the vehicles, and also by identifying whether your vehicle is deviating from the traffic lane. That is another method, and that is kind of the work of predictions can be done by using artificial intelligence algorithms. So for that, you need to collect the data. The IoT is the basic requirement. You need to incorporate your machine learning principles into that. Then the prescriptive analysis, also some immediate. So something to be done. Some disaster is predicting by somebody. So you know that the tsunami, we talked about tsunami, and now I don't know, there are some kind of immediate prediction is there. Some sensors are deployed in the sea, but I don't know how fast it will be reached with the people who live in seashore and all, and to evacuate how much time they will get. But there are some hardcore research is happening in this area to kind of some immediate predictions. When recently there is an unexpected flood happened in Jharkhand, and the bow went down. Those things were, I think, almost more than 100 leaves were there right below. So it can also be, I think, identified. Maybe if you use it intelligently, we have some sensors deployed and make the predictions or make the decisions immediately. Then coming to the adaptive and autonomous systems, that is a big scope. We always talked about the autonomous car that we are going to get very immediately, and also things more than the vehicles, the devices in around or all around you. Even you can, the ladies can enjoy the benefit of the adaptive and autonomous systems in the kitchen. Sure, there are some works already been there and product is available in the market. So you can see that if you put these two technologies together, the facilities that you're going to enjoy in the future will be that even that is beyond our expectation, I'm sure. So they hardly just going to, I'm not going each and every point, but these are the 4 different segments we need to consider. Those who wanted to research, do the research, or continue some studies in this area, you can look into these 3 areas. One is the wearables, which will be the there is wearable IoT and flexible IoT people talked about in the health sector. And also the fitness. Health means definitely in the sports, etc. This IoT, which can be attached to your human body. It's a lot of research is happening and a lot of developments are there. And it will be almost $87 billion in revenue by 2023. So there, I think this that the merging of AI principles with IoT can contribute a lot. Next, I was just talked about the kitchen, smart home, security, etc. Then I will be explaining a little bit more about smart city in the next slide. So I'm just skipping that. Then the smart industry, the productivity. So you need a product now which completes the cycle the very fast, because there are a lot of competitors there. So you need to have a smart production facility in your industry, then only you can survive in the market. So even there are a lot of works, even 3D printers, and there are a lot of development happened in that one, already progressed area. Even in the automotive industry, you can see that these AI techniques have been incorporated in their machines now. Even but only in the very higher end manufacturers, not in the lower end manufacturers, but it is coming up. So these are the 4 segments that you can see that where the scope of AI and IoT can do some can initiate some changes. So coming to the smart city, earlier you know that in India there are 100 smart cities. You can see that there is an IODX platform which is called India Urban Exchange, Urban Data Exchange, IUDX. It's called IUDX. So already that initiative is there. And to collect the data, the idea is to collect the data and share the data for the research and to provide better services. So coming to the management systems, you go to this picture. Mainly, you can see that basically the management systems here. The service sector, the scope of AI IoT is much bigger. So in the smart city, basically, it should be the priorities will be given to avoid the traffic conditions or the big crowd. So there is something called crowd monitoring, traffic flow monitoring. Sensors are deploying in our cities. So with that, by using the data collected by using these IoT sensors, there will be some machine learning models used to predict or provide some kind of priority to the people, those who are entering to the cities in later, and also for the vehicles. And next, we now talk about not only smart cities, smart sustainable cities. So the environmental conditions and also economical sustainability is to be considered. Environmental condition, you know, now even in the city which I am living, recently we witnessed a very big flood due to when the raining. It was not witnessed earlier, but you can see that now the quantity of the water that is coming in a short time is very big. So we are not supported with the enough drainage system to consume that much of water. So you know, because of the infrastructure development, the water flow is not properly happening. So some kind of intelligent activities should be incorporated in future. So otherwise you will lose the more lives in this kind of incidents. So not only smart, making the city smart, and the importance is to make your city more sustainable, and that is important. So there is also that you can see that this IoT together with AI can do a lot of works. And coming to the the bottom part, you know about that one, I already been covered that one. So straight away in the ICT infrastructure, you need to build that one. So because many speakers have already talked about that one, so I'm moving to the next slide. This is also almost similar to that one. I'm just consider the use cases of AI in IoT. So mainly on the left side, you can see that in the industrial part, the manufacturing, energy, healthcare, retail, telecommunication, and government sector. And in the consumer IoT, in the remote management, real-time diagnosis, then connected homes. Similar to the connected vehicles, there is some new concept called connected homes, where you can connect the individual households to share the facilities and to enjoy the better better services, right? And also the health and life cycle. Then this science definitely in the, you know, that the robotics, medicine, and everywhere, wherever we are using IoT, there we can use this AI together, and you can see that some of the outcomes are much faster than expected. So that is the beauty of making these two technologies combined. So that is why now there is a new term, and that is called artificial intelligence of things. Artificial intelligence of things, putting together, and I'll come to that part, and I'll put more time in explaining that what is the current status and what we need to do in future. So then you can see that these are the three hot topics which is connected to the IoT. One is the artificial intelligence. Second one is the 5G network. It's for the connectivity, for the sensor network and all. You need a at least 10 GB of bandwidth to transfer the big data. So next is coming to the third part is the big data, because you see 42 billion of data by 2025. You can imagine that how much data is being collected. And all this data is going to be stored in the cloud service. That is, there are cloud storage providers, but that is not sufficient for us. So that is another hot area. That is, but that is come to the right side image. You can see that wherever you can see that the AI comes into the picture. Where AI is coming into the picture. You can apply your AI principle to the building intelligent edge, or making intelligence to the edge, or manufacturing intelligent there, or providing intelligence separately. Then edge computing, where you can do some kind of data processing there in the edge. Then coming to the data processing also, you can do some smart processing to the filtering of data. Then AI is finally, after being stored into the cloud, the data can be used for some applications. That is currently happening. So these are some potentials that you can see that currently we heard about Alexa, the smart speaker. We have some smart thermostat, smart appliances in our home. And also massive object detection is happening. That is only because of that AI in the vision. You heard about computer vision, and also the speech processing AI is used, and edge computing AI is used. But in tomorrow, you can see that with the help of this IoT, Internet of Things, having more real-time data, you will be using robots in your home. You will be using autonomous vehicles even in your village. And you will be communicating with the people who not belonging to your native language. So you can use your native language, and the other person will be using a smart headphone, and he is listening to your conversation in his language. That is going to come very soon. It's already been completed the work, I think. Then e-payment is now, we need to initiate some kind of barcode or initiation, but only the voice authentication is going to come. Then the video analytics to the human mobility, healthcare, etc. Video analytics is going to emerge. So these are some untapped potential of AI IoT that you can see that, and it is not very far. You can see the outcomes of these two merging, right? The combination of these two technologies. Yeah. So coming to the little bit more into the this area. So only those who are interested to do research, you can concentrate on this one, and I can really help you in future also. So you can see that now artificial intelligence, you can divide this into 4 segments. The complete IoT network, you can divide it into 4 segments. One is your on device, the sensors, mainly we talk about the sensors. Then something called edge, your camera, those kind of things comes. Then finally the cloud. So to bring artificial intelligence to the IoT devices, you can bring the intelligence to these 3 segments. That is to intelligence to the devices of basic sensor itself, then to the edge devices by putting edge intelligence. Next is the cloud level kind of artificial intelligence that is already being done. You can see that the second figure in the right side, you can see that now you heard about AWS and also Microsoft Azure, then a lot of other cloud service providers where they store this big data, and they build their own deep learning models for the predictive analysis or the kind of making some adaptive systems, etc., etc. So the main concern in this kind of artificial intelligence for IoT domain is you need to transfer the entire data from this data source to the cloud. So the application will be or the benefit of this AI IoT will be used by some consumer. So the consumer also how to get connected with the cloud, because your machine learning or the deep learning training is happening in the cloud, and also the inference is also happening in the cloud. So it needs definitely a data connectivity, a good network. If the network is not in good condition, the service will not be, or service with get halted. The other thing is that the bandwidth of the connectivity, the communication network that you are using, there is again problem. The billions of people are using these edges to for AI IoT. I think there will be a very big problem to the communication network. So what happened was this kind of bigger data processing is not required. You know that in artificial neural network, where it does a training, the machine learning concept is nothing but we build a machine learning model or deep learning model. We train the model with an exhaustive data, and we validate the model by using another set of data. Then this trained model is put into the service. So the real-time data can be applied to that one. You can get the output of that one. So at the time when you do the training, only the use of the very big data is required. So now what they do that to avoid this traffic congestion and also to reduce the latency of services of AI IoT, they are bringing down this inference only to the edge. You can see that the second part is edge. This is end devices. This circle is end devices, and this is edges, and this is the cloud. So the training will be happening in the cloud. Then the inference, the train model will be deployed in the edge. Then the inference only will be happening in the edge. So the use of, because the problem with you can ask why don't these edges can do the training? You know that the microcontroller, we will be using Arduino, Raspberry Pi, even Cortex-M processor or FPGA or something to the making these edge devices. The memory resource, memory storage capacity is very less. And also, you know that this deep learning kind of algorithms is parallelly performing a lot of operations. It requires even multiple CPUs and multiple GPUs. Even after that, it takes, if it does some kind of computer vision algorithms, it takes many days to complete the training. So you can just imagine that if you do those kind of training in the edge devices where you have very single core processor and the very less memory compared to this one, it is very difficult. But there is some facility, this Azure, Microsoft Azure and AWS is now providing those for this kind of services. They are supporting this kind of services. But now the question comes: this issue is persists only because you need to work on big data. Is it that much required? Whether you need to have more data, because we already know that the AI models, artificial neural network, if there is more data to train, the accuracy will be more. Like that, we already learned, but the question comes there: how can we make this training happen in this one? And is the machine learning inference is possible in the end devices? That is the now question, and that is the topic to be considered for the future research. You can see that. So moving to the next slide, and the right side diagram is actually talks about the edge. What is the intelligence, or especially if you talk about AI IoT, now this diagram shows the complete information. That means there is kind of called vanilla neural network, that is the single hidden layer network, which can be used. Definitely the accuracy will be much lesser than the deep neural network. But there is something called federated learning, where the data will be used efficiently. And in addition to that, now people are trying to reduce the size of the data and the size of the deep learning models, so that it will be efficiently deployed and trained in the edge device itself. And the advantage is that you don't need to communicate it with the cloud. So the edge devices, mostly you will be taking into your hand, or it will be very near to the data source. So the training of artificial intelligence models or deep learning models is happening in the edge. The inference is also happening. So you can imagine that this latency, that means the time that the request you are giving a request and the service that you are getting back, that will be reduced more than 200x. Some experiments have shown that it's reduced 200x. And also the memory requirement is coming down, data storage requirement is coming down. So the entire service is going to be it's improved a lot. And the most interesting beauty of this kind of work is that the cost that you are spending, the computer, more than the computational cost, and also the manpower, everything will be get reduced, and you will be enjoying the facility of artificial intelligence in IoT in the device which is with you. That will happen. It's already being there, and some of the products are already being there. I will talk about that. But you are going to enjoy the benefit of all these AI IoT in future in all the segments, not only the segments which I talked about. You can see those developments are happening. Even you just search in the Google Scholar, you can see that number of publications are coming. In last 2 years, not only the data, in last 2 years, you can see that the number of publications is almost 10 times double, right? 10 times increased in this particular segment. So now coming to the second phase, my introduction, those things to talk about the relevance of AI IoT, I tried. I hope that it has been reached you. So we are moving to the little bit more into the intermediate learners, how we can do all these things in practically. And I think before moving to that, I think if some of you have any very important question or any suggestion to for this one, you can, those are welcome now. Fine. I think I was audible to all of you, right? Some of you can respond. Can you?
Yes, sir, you're audible, sir. Please, sir.
Or shall I continue, or if
Yes,
anybody
sir.
is not
clear?
Fine. Okay. So this is the thing is that we are coming to the a little bit more into the AI and how we can deploy your AI model into the IoT devices, and I think we can just understand what are the issues associated with and how can we overcome that. So this slide simply shows the basics of ANN, artificial neural network. So I'm not talking about all the models in the machine learning. You know that there are some of the small models from the linear regression model, random forest, SVM, then kind of that is clustering models, etc. Anyway, it can be classified into classification and regression models. So we use it for predictive analysis. We use these regression models, mostly predictive analysis. Then for the immediate kind of the classification, we do that classification model. So I think for IoT, the machine learning both and also deep learning models have its own importance in IoT domain. But the question comes when, or the main challenge comes when deep learning is used in IoT. Because you know that the deep learning, there will be more hidden layers and the size of the model will be much higher. And also, you know that this deep learning models or networks is mainly for the big data processing. So the issue of latency, memory size, etc., energy efficiency comes where the deep learning is there. Also, you can have your machine learning. Small tiny models are already available. It's according to the requirement of the application or the segment that you are working. So, but I concentrate my talk basically on the deep learning, where the large models are being used in IoT. So, so these are the some basics of that. You know that neural network is being is structured in a way that there are some input neurons, then some hidden neurons, and there is an output layer. And this is called vanilla network, which we have seen there in the edge devices. We use now in the edge this kind of very small network. We cannot call it as a deep neural network, but it is called vanilla network. But it is sufficient to provide some kind of intelligent services to the edge. So it is being there. There are some intelligent edges already in the market. Vanilla network is being used and federated learning is used. But there are some problems with that in terms of accuracy. You know that when you have more deeper layers or dense layers in your network, you can improve the accuracy, because sometimes your data is not that much visible and data is not clear. But providing more bigger network and providing more data, you can make your accuracy more. There are certain other aspect also in this one. You can reduce the number of neurons. Even if you have a dense network, there is a method called pruning. If you apply this pruning, number of neurons will be reduced, and you can reduce the size of the model. So we will come to that part later. And this is talked about simple deep neural network. And coming to the other type of deep neural network is very simple. One is the recurrent neural network. It is called long short-term memory. I'm using it here because this is also very commonly used in all these kind of predictions. When you have a time series data for the energy, dynamic energy prediction, traffic flow prediction, whatever you take now, if you have a history of data with you and if you want to predict something in future, you can use the simple network. It's very simple. As compared to the your CNN model, the size of this one is it's very less, and you can easily deploy it is in the IoT. That is why I just mentioned it here. LSTM, long short-term memory. So the just you can look into the equations that you can see that the prediction y hat and also the activation that you can see here, or the forward propagation that you can see a hat. Then that this is called activation function tan h, and W is the weight and B is the bias. Just to see the other, those are not very familiar with machine learning or deep learning. Just I'm introducing this one because we are going to talk, continue our discussion based on these three factors. One is the bias, this is the weight, and this is the activation function, right? The softmax is also an activation function. This is the output of the network. And something called in LSTM recurrent network, you can see that some input gate, then forward gate, forget gate, memory cell, etc. And all these some mathematical expression can be used to denote that one. All the networks are working on forward propagation and backward propagation for this optimization, or the what to say that training or reduce the loss. This also works on the same. So actually what happens is inside of this neural networks is you can see that these two processes happening. One is the multiplication and the other one is the addition. And you can see that all these are the matrices. So the multiple inputs can be applied as, you know, the vectors, then the process will be easy to do. So I'm coming to that part now, just to these are the different available and widely used neural networks. And interestingly, all these networks can be converted to an IoT implemented mode. That is the beauty. Now we are coming to how to use it, and in the next few minutes we will be moving to that one. So I'm not spending much time because already we closed 1 hour. I think so. This will be for the participants' attention. You can go through and search this informations are there in the website to understand the basics of deep learning networks. It is not very hard to learn. That is what I did in few months back. That is what I'm telling. So it should be necessary if an essential thing to understand the basics of deep neural network to do some work with AI IoT. So the problem with this neural network, I'm going to talk about that. So this you can see that it's a deep neural network consists of input layer, many hidden layers, and output layer. When it comes to an image processing, suppose we are feeding this neural network with an image where there are 400 by 400 image pixels, and you know that there are 3 frames RGB. In a color image, RGB frames are there. So you can imagine that the number of inputs from X1 to X480000 it comes. That much of input neurons will be there to process this image or feed the input pixels into the neural network. So you can just imagine that the previous situation that we are showing it for one particular neuron, so that how many computations will be happening with that. So you can see in the bottom part number of parameters. The parameters are nothing but we talked about W, B, etc. Those are the weights, bias, activation. Those are called as the parameters and hyperparameters. So the approximate number of parameters in this network to the network which is designed for 400 by 400 into 3, a single an image processing, you can see that there are 230 billions of parameters there. You know that all these parameters are numbers. Number means it is in the floating point number. You heard about single precision and double precision floating point number. Most of the deep learning libraries use like TensorFlow and PyTorch use float 32 number system. So you can imagine that this much of 230 billion of parameters in 32 single precision number. So how much of data storage is required? Is it possible? So you know that, okay, there is a convolutional neural network game where the images will be convoluted and the total number of frames will be reduced to 1,000 or less than 1,000, etc. That is called the beauty of convolutional neural network. So you can see that I have shown that in the second calculation, you can see that this is using this convolution. Feature is extracted from the image without altering the quality of the image. So those is CNN. That is why CNN is widely used in the artificial neural network applications. So the size is reduced to the 480 million. But again, you can think about how much number of parameters and how much data is required. And think about that to do this is in the cloud or a bigger machine, and the training is happening with the support of high-end CPUs, i7 or i9, or a server Xeon processor, and with the support of the latest graphic processors from the NVIDIA, may take some 24 hours. It's hardly in hours. It will be in hours and it will be in days, the training. But you can imagine that, our Raspberry Pi and Arduino, and also even Cortex-M microcontrollers we used in developing IoT bar edge devices is having a memory of 1 MB, 2 MB or less than that, right? So, and the processing core is single core. Some 32-bit microcontrollers are available, but thing is that it's unimaginable. We cannot even think of deploying or doing a training of these deep learning models in this kind of IoT devices or edge devices by using this much of data. So these are the main challenges of AI in IoT. That is storage is the problem. Then the computing power is the problem. Then definitely time for training is the main problem. So coming to that part, but it is now happening. I told earlier that it is now happening. How it is happening? It is like this. There is something called reduced precision concept. And there are many other methods to reduce the number of neurons that I said, that is pruning is there, and weight sharing. Those principles are used to reduce the number of neurons. If number of neurons are there reduced, definitely that functions will be, the computations will be less. In addition to that, we reduce the precision of the weights and bias that we use. So I told earlier that most of the framework, that is TensorFlow and the PyTorch framework, uses the float 32 number system for representing these weights and the parameters. Parameters means the weights, bias, and hyperparameters, etc. That activation functions, etc. Then the concept came, that if we can represent a number in an integer form. You can represent the number in half precision, that is 16, float 16. You can represent a number in the single precision, 32-bit. You can represent a number in the double precision, 64-bit, right? The only thing is that the size of the number that you can represent will be higher in single precision. That will be, maximum value will be 3.4 into 10 raised to 38. It comes, right? This is the single precision IEEE standard that you are seeing here. So because already been gone through this one, I'm not exploring much, but the only thing you remember that this TensorFlow and PyTorch is using this float 32 number system inside to represent your weights, parameters, etc. Now bringing down into the half precision. For example, if you're representing those weights and parameters in half precision, 60 number, definitely the memory requirement will be halved to store, and also the time for processing will be, the computation time also will be doubled, right? But the problem is that the maximum value that you can represent will be less. So what happens, the number of maximum, the value is less. For example, if you have that floating point number 2.61345, because it consists of more information. If you're reducing it to 6.14, the remaining 2 digit part will be over. So that means you are losing some kind of information. So that is the only thing happen. Your model will work, but if you reduce the precision, what happens? Some of the information will be lost. So ultimately, what it happens to the deep learning or machine learning model? Yeah, in the end, it will be reducing the accuracy there. But if you can complement that with some techniques to increase the accuracy, or some kind of mechanism to reduce the precision without affecting the accuracy, that will be a interesting thing, right? So that is done now. Thing is that the intelligent kind of mechanism that is there. So I'm just skipping these basics of these things a little bit, since because you already know about this integer 8, float 8, etc. Then even you can represent your weights and parameters in integer 8 format. Only thing that only that integer 8 you can represent only 255 numbers. Only that much of weights and parameters we will be able to apply. That is a problem. And also there is integer 4, integer 2, binary neural networks, etc. is now currently coming into the picture. You can imagine that about. You can see that the floating point 32 number, it can be reduced to the integer 2 value to represent the weights and parameter weights, bias and activations of your neural network. So ultimately, it will reduce the total memory size, and also the computation time for the training, etc., etc. And we are trying to make the model fit into the less memory edge devices. That is now happening, but there will be a minor reduction. So there are intelligent researchers have come up with a lot of research ideas. There are a lot of published papers. Even Indians have contributed in that one. But you can see that those who have already published wonderful work in 2019 and 2020, you can see that all of them are now is working as the research engineers in the Google. What the Google will do is that those who do a publication in this area, they immediately comes and pick those people, and then they make those people to work in only for the Google, right? So they can come up with some solutions. Now, you know that even the deep learning and machine learning is not a big problem for those who are not familiar with this programming. You can easily build your model by using the Google supportive APIs right now. Similarly, they are coming up with all this process, because this is a very hard area of research in last 2 to 3 years. This quantization or reducing the precision, pruning, Vinograd transformation, etc., etc. But you know that the Google, they came up with a product called TensorFlow Lite. Now everything becomes very easy. You no need to worry about how can you reduce the precision from 32 to 8, and what will happen to your accuracy. No need to worry, because they will take care of that one. So, but not is completely that feature is extracted, but it's coming and people have started using it. So that is what I have shown in this slide. So the mechanism is currently using now. They don't use this reduced precision for the weights and parameters now in the training. They do the training. So that is the interesting part. The training cannot be done in the IoT devices if you use this one, right? If you use this technique, you cannot do, because the training you need to have bigger weights and parameters in 432. So it requires more computing power and memory. But after the training, what you do, you will convert all these parameters and weights into the integer 8. That means for inferencing, when you do the real-time data and when you want to use your deep learning model or network for bringing artificial intelligence to your IoT node, you can deploy it there, because you are not doing any further training there. So it will be giving you the output, the almost similar accuracy of your training, what you're getting in the training. That is the interesting part. So only thing is that you cannot do the training here, but you can get the benefit, you can enjoy the all benefit of artificial intelligence in IoT. So inference with 8-bit happening without much reduction in the accuracy. And that is why this tool called TensorFlow Lite is used. The same explanation is there in a little bit more broad way, and there are some disadvantages. Coming to the just avoiding this, can see that even it is more than 4x. I will show you that. Disadvantages of quantization is nothing but its accuracy will be reduced, but it is only up to the 2 to 3%. That is acceptable in some cases. Where accuracy is a critical component, you cannot do that. But in some cases, you can see that accuracy is not that much of important. In that case, all you can apply. Then the thing is that all the microcontrollers that you are using to build your IoT node will not support this. So your IoT node or the IoT microcontroller should be able to accept this kind of machine learning. So that is important. So you can see that the platform that you are using now for the deep learning or machine learning is TensorFlow and Keras. With Keras is suitable for this one. Only you need to use some additional APIs. PyTorch is coming up with quantization, and this is something called interquantization is not yet has happened. That is why I put it there. It is coming up. There are more people are coming up with more tools. Then the problems on it, the deep learning or this particular process is that there are two methods. One is these framework providers are giving you trained models that you can take and convert it into, you can use it for the inferencing. Second one is you can build your own model, that is called custom model. Custom model you can build, but you know that all the libraries will not be supported by this quantization. It is, but in coming years, you can see that it will be a common tool to use with all the deep learning or machine learning libraries, this quantization technique by using TensorFlow Lite, and that will be overcome in future. Then in future, there is currently the research is happening in the field, the quantization aware training. How to do the quantization before training with the parameters. That is called quantize the parameters and then do the training. Quantization aware training. Mixed precision. How to combine or intelligently switch between the float 32 and float 16 number systems, right? So it will reduce the memory model and computation power to a certain extent, and some kind of new floating point numbers called brain floating point 16, etc., which also may reduce all these or avoid the challenges of AI IoT to a certain extent. That's currently you can see that research papers are publishing. And I just brought to you about some more details with the what all processors will support this one. You can see that there are a number of boards, mainly ARM Cortex-M will support this AI IoT, and also ESP32. It's widely being used in IoT. You know that ESP32 is even we in the smart city design, we use this ESP30 to build most of the IoTs along with the Raspberry Pi. Even Raspberry Pi also will support this deep learning, because I not included it here. But you can see that n number of development boards. These are the IoT development boards that you can see that ESP32, ESPI, etc. Even now Raspberry Pi is into the market with a Pico board that also will support this one. So I think those who want to build some of the IoT applications, you can think of bringing some of the services in the intelligent services in the IoT node, so that you can reduce the data that is being transferred to the cloud or the other services, and you can intelligently do some process in the node itself, IoT node itself, and make the decisions and provide the services according to that one. That is really interesting part. And then I will show you that it is being talked about. It seems to be easy, but it's a lot of research is to be carried out in this area, but people are more interested in that now. And thing is that the development, so the scope of research is you can see that's a broad area of research. Even you see that it's very easy to say that AI IoT, but it's a broad area of research. And the benefit of all this AI IoT, the peoples of the developing country like India will be enjoying that. Now it's AI IoT is used by the peoples in the upper class and the middle class. The lower class is not started using the benefit of this AI IoT, but I'm sure that like you, the researchers and more students of yours come together and do build some of the interesting applications by using these two technologies, that you can see that it may lead to some innovations and even building enterprises in the future. So coming to the, I have 10 more minutes. Coming to the how it can be done, the workflow. So there are two methods. One is you can train the model by your own, and you can pick the model already provided by the TensorFlow. Then convert the model using a converter. It is already a library available to convert the model. So which does the kind of pruning optimization inside. Then you can deploy the model. And finally, there is a post quantization. That is finally you can convert it into the integer 8, float 8, 16, etc. Whichever you want, you can do it. And next is that you can train your own model. You train your own model, then convert it into a TensorFlow-like model using this converter library. Then deploy it into the IoT. That the microcontroller, and for mobile devices, separate interpreter is available. And this will not require any kind of operating system, only a C++ library is required in the microcontroller. So you can deploy it and you can enjoy the AI experience in the microcontroller itself. But you can see that it will be, if for example, some of the microcontroller is having 1 MB, so we can even have a deep learning model with 20 KB of size. I will show you that results that we received now. The limitations still there. Not all operations will support this quantization or the conversion. All the libraries in the TensorFlow 2.0 will not be used to convert it. It is difficult. So also the similar set of devices, the only C++ API is requiring manual memory management, on-device training is not yet supported, but in future you can see that this training is happening in this one. So I will come up with this very small demonstration and a very small example that we have done. We are doing it here, and we use to build an LSTM deep learning model for the traffic flow prediction, and we use the PEMS data set from the Caltrans University. A particular road and road station is concerned, and freeway SR99 is concerned, and we use the different libraries of NumPy, Pandas, TensorFlow, Matplotlib, etc., Keras, and the platform, the operating system. Seems these some of the interpreter in the microcontroller. This one will not work in Windows, so we need a Linux-based operating system. We use Ubuntu in that one for the interpretation, but the conversion can be done in even the Windows also. So the interesting thing, these are some of the details of the model that we used, because this presentation was used for some other purpose. So you can see this coming to this optimization. You see that this is the work that we have completed just now. If your LSTM is having 32 units, the model actual model size is 32.16 KB only, because it works on not on images, only time series data. 32 units. If you convert it into TensorFlow Lite, it will not be reducing. That is only some parameter optimization and the cloning is happening, only reducing to 29.44 KB. Then finally, if you convert it, if you apply the quantization, you can see that the memory size is reduced to 18.41 KB, almost half. But that conversion is, or reduction in the memory size is much happening in the large LSTM model, 256 unit LSTM. You can see that it's almost 1 MB. The size is almost 1 MB, but the light conversion is not happening properly. Its size is increasing, but that is because it is only with LSTM. CNN means it will be definitely reduced. But if you do the quantization, the conversion of 8 parameters from float 32 to the integer 8, you can see that this is integer 8. The size is reduced to 278.6. That much of fact, that is almost the 4x of reduction is there. And the interesting part, you can see the error values. If you look into the mean squared error and mean absolute error of the quantized model and the original model, you can see that there is only a reduction of only very, very small values of MSCs. You can see that even the 64 to 56, you can see that just error is increased only 1 to the extent, right? So both the errors. That means this model is acceptable. This method reduces the memory size by 4x without affecting the accuracy much, right? So this is efficient method for the artificial intelligence in IoT. It has been proven. And you can see that we applied the same concept with some other models. That is, that the transfer learning BGG19 is there. And it's only for MNIST database. I will show you that demonstration if possible. It was size 1 MB, 1.19 MB. It was reduced to the, you can see that 100 KB. And a dense layer, which was earlier, originally it was 200 KB. You can see that it is quantized to the 1 KB. That much of reduction in that particular case. But that tensor layer cannot be applied for any image or those kind of processing. But we took it as an example. These are some of the graphs that we are showing. So we experimented it, and we came to understand that it can be, this concept is can be extensively applied in our smart city research project. We already done it there in the sensor calibration. We have a problem with our sensor was not giving accurate reading because it was sensitive with temperature. So the calibration was not properly happening with the technique that the manufacturer was saying, but we used a very simple technique to linear regression, and we came up with a solution. And there are some other people who worked on this one, and they're applying for patent. So there are many things to do. It's a very interesting. You also can get the information and tutorials from the web, and also I can really help you if you text to me if anyone is interested in future. So as a conclusion, I'm coming. So you are mainly hearing a lot of things about IoT. you are about to learn many things in the afternoon also, Arduino controller, etc. So just think that in IoT, if you bring AI, the benefit that you are getting, it becomes intelligent and it's able to process more data, and it will be able to learn by itself. That is, intelligence will be there, and it will be able to self-monitoring and healing. There are some kind of calibration error or any other kind of error. It will be able to heal itself. That may reduce the maintenance cost. And autonomous kind of decision making is possible in your IoT. These are the benefit. All other concept that you are not going to change, that you're going to learn, that you learn already and going to learn about IoT is not going to change. Without changing those all principles, you can bring AI into artificial intelligence principle into this one, into the IoT by using these simple techniques. There are more facilities to come to reduce the size. I think researchers have carried out. You can expect it from Google itself. So I think it will be very useful even in all the segments that we talked about in the beginning. So I conclude my talk, and I just wanted to show you before conclusion. I just wanted to show you one video. I don't know whether that will work or not, because I want to just show it only because just you need to understand that how it all came, right? And what is this, you can see the happiness of the engineers, those who worked too hard for it. I don't know, is it the video is visible to you now? Hello?
Yes, sir. Yes, sir. Please, sir.
Just tell me that you can hear the audio.
So,
Yes, sir. We can hear it, sir.
I'm pleased to announce that we are releasing the first experimental support for embedded platforms in TensorFlow Lite. And to show you what I mean, here is a demonstration board that I actually have in my pocket. And this is a prototype of a development board built by SparkFun, and it has a Cortex M4 processor with 384 kilobytes of RAM and a whole megabyte of flash storage. And it was built by AMBIC to be extremely low power, drawing less than 1 milliwatt in a lot of cases. So it's able to run on a single coin battery like this for many days, potentially. And I'm actually going to take my life in my hands now by trying a live demo. So let us see if this is actually. It's going to be extremely hard to see unless we dim the lights. There we go. So what I'm going to be doing here is by saying a particular word and see if it actually lights up the little yellow light. You can see the blue LED is flashing. That's just telling me that it's running inference. So if I try saying yes, 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 I knew I was taking my life into my hands here. Yes, there we go. So I'm going to quickly move that out of the spotlight.
That was nothing. It's the first demonstration of an edge device deployed with a voice recognition machine learning algorithm. And this is Pete Warden, who designed TensorFlow Lite, and you can see the happiness in his face when he demonstrated it for the first time in 2019. Even though this is a very small model, he knew that he is going to make a lot of changes in future. You can see the happiness with him. So this edge device that he has shown is only cost around $15, almost less than 1,500 rupees. Now you can deploy this your deep learning model into that one. It's from SparkFun, right? So now, hello. Anybody? Hello.
Yes, sir. Please, sir.
I think hope all of you have viewed that video.
Yeah, yes, sir.
Just one more, the final one. I'm going to just show that one is this Jupyter lab is visible to you?
Yes, sir. It's visible, sir. Please.
Yeah, that I'm just showing that to that one result we have shown that one VGG19 model now, that I'm just showing that how it can be converted. So you need to do all this your deep learning as usual. You can see that you can execute this is MNIST database, mainly a fashion data MNIST data set is here, and you can see that maybe the screen is not visible that much. I think now it will be more. You can see that this is to predict a class of information. So we'll come to that part. So training is already done. What I'm just showing that this is the size of the original model that we are getting 1.19 megabytes of data. See, now, the thing is that we can apply TensorFlow Lite. These are the only 4 lines of code that you need to use. Convert your H5 model. You know that you will get H5 or JSON model of your deep learning, the structure that you already built. So use that H5 model to this H5 model fashion MNIST H5 to convert it into the TensorFlow Lite model. Use this only this much of converting code, only 3 codes I'm using here. And now you can see that after conversion, it was reduced to the 1.101 kilobytes. That is the beauty of this TensorFlow Lite to do the quantization. No need to worry about what is happening inside. Just use these few APIs to convert your original deep learning model, which is of 1.19 MB, to get it into the 101 KB. You know that 101 KB is not a big memory to utilize in the, you can use it in the microcontroller. Am I right? So this is the beauty of using the TensorFlow Lite, and there are many other framework also going to be available from Intel, PyTorch, etc., etc. So you can later compare and you can just come to the best or optimized method for that one. Now I think it's a time for the question answer, and I'm just concluding my talk here, since it's almost exceeded my time allotted for me. I once again thanks all of you for, even now we can see that there are more than 40 people. All of you are very hungry. I know it's your lunchtime is over. Thanks for being here, and thanks for listening. And I thank all the organizers for giving me a chance to speak to you. And I welcome the participants, those who are interested in doing a collaborative research or a collaborative learning, whatever things you want in this area, because research is still going on. And I encourage asking doubts. I'm free, but it all depends on you. If whatever I'm possible to answer, I'm very happy for that. Thank you. Yeah.
So thank you, sir, for your wonderful session. It was quite informative, sir. So we have a query in our chat box from Murthy Veluchami, sir.
Fine.
Which controller is suitable for deep learning in end device?
Deep learning in?
End device, sir, end device.
Yeah, that is what I just shown in my my slide. I think already ESP32. There are a lot of microcontroller ARM, Cortex M, ESP32, even Raspberry Pi that you can use. It's there. A list is given in the website of TensorFlow Lite. You can just directly browse into that one, and all the supporting libraries also they provide.
Thank you, sir.
Thank you. Yeah.
Welcome, sir. And thank you, sir, for a very informative session. Again, thank you, sir, by Priyadarshini ma'am. And excellent session by Dr. Piyush, sir.
Yeah.
So I request the participants to unmute yourself to raise queries if you have any. Else you can use our chat box to ping your queries.
Okay, I think it's fine. I think people are in a hurry to have their lunch, right? Now they can contact me. My contact details are already with you. If somebody wanted to get that, definitely you can pass it to them. Okay.
Definitely, sir.
Fine.
We'll share your video link as well as the session PowerPoint at the end of the program, sir.
Sure. It's already
Thank
being
you, sir,
laid.
for accepting our invitation, and you have given some informative session throughout 1.5 hours, sir. And on behalf of GRG Polytechnic College and Instrumentation Control Engineering, we extend our heartfelt thanks for this session, sir. Thank you, sir.
Thank you very much. Thank you. Yeah.
Thank you all for being patient throughout the session. And I request the participants to resume back to the session by 2 o'clock to have our third session. Thank you. The feedback link has been posted in the chat box. I request the participants to fill up your feedbacks.
Thank you, all of you. Thank you very much. Bye. Have a nice day.
Thank you, sir. Welcome, sir.